All right, let's see what we got going on here. Looks like we've got Lily cam up. Lily's going to be here for the rest of the day, so we'll kind of keep an eye on if Lily pops up over here. What are we doing today? We're hanging out and talking shop about just the sysadmin course that we're running. We're in week 15 of 16, so that's kind of going. I was cleaning up the home lab a little bit last night and working with you guys on stuff. So, yeah, that's kind of where we're at. Where are my teeth? How's it going? Never fear. The Boris is here. How's it going? Yeah, we're just kind of, working through things and got a lot of stuff to do, and I got a lot of actual work to do this weekend, so I'm kind of like just messing around here before. Let's see, I got in about 4 hours, I've got 3.5 hours. I've got my college students. I got to hang out with them for a little bit. We do like a study session on Saturdays, so I'll meet up with them. Thanks for the resubscription, Boris. Now you don't have to watch ads, so that's kind of cool. Yeah, but all in all, we're just kind of checking out the environment, making sure things are working like we expected. I'm kind of slowly moving towards. Oh, I didn't even show you guys this. Hold on. I actually did buy the upgraded version of Excalidraw, so like I'm paying for it now. But there's some pretty cool stuff in there that I'm going to use for some of my presentations. But things that we're working on now as far as like in the home lab here. Let's see if I can close this down so I don't have to see it. We're going to be moving the Bastion node in place of P01 Jumpo 1. So we're going to be moving the two nodes. We've been getting those ready. I got to get fail demand working on there still. That was a limitation that we had. Just little stuff like that. So we're just kind of slowly moving towards like a working system. Zorgle's here. How's it going? We are, again, not working too hard. Just kind of checking on some stuff. And then what I was going to do was I was going to give you guys that maybe aren't going to be here for later, or even if you are going to be here for later, kind of a rundown of what the course looks like. So this is the Linux Systems Admin Unit 15, right? There's me. Tell you guys all the time, I'm a real person. You can find me online if you wanted. But we're going to do Unit 15. It was originally from December 21st of last year. I need to strip all those off. But this week's course is on troubleshooting and systems engineering and those kind of things. So while it is a Linux administration course, we do touch that next level job for admins, because admins are typically where you start and then you move up towards like your engineering type roles. Okay, so thanks for the follow. I'm just gonna call you Gene. But anyways, these are the announcements if I have any, like if I'm going to be out of town or something like that. I don't have any more. We're going to do Unit 15, and then next week we'll do Unit 16, and then we'll be done. We will finish the course off. Typically, I give another week for people to finish their projects. So we'll probably say on the maybe like August, what would that be, like August 9th, I would give another week. Yeah, so probably like till August 9th, you guys could still turn stuff in if you wanted. That would be fine. All right, so let's get over here. What did we do last week for people that are following along with the course? We were doing automation, mostly with the tool Ansible. We talked about how all automation is futile. All systems administration, all automation, and all security, at least those three things, but probably more, are useless if you don't have a good inventory. And you say, prove it to me, Scott. All right. You think you have 820 servers in your environment, but you actually have 1,000. Can you you think you have 820? Can you administer them? No, because you don't even know what the other 180 are, because you don't know what they are. Can you automate them? Oh, hell no. You don't have them in your list. So you don't know what you're doing. And can you secure them? You don't even know they're there. They're just like a little, an infection off in your system that you can't even track, and you don't even know what's on them anyways. So it's a way to think of the system, but a lot of administration, security, and automation comes from a good inventory. In fact, I would argue all of it. If you don't have a good inventory, you don't know what your starting point is. You can't shoot a good azimuth to wherever you want to go. Raleigh, how's it going? Hopefully this stuff's useful to you. Ow. Hopefully this stuff's useful. I just busted my fingers on my desk. Also, this finger is really sore. I almost broke it yesterday in jiu-jitsu. It got caught up in somebody's gi, and it ripped my. I've got one of these little. I don't wear metal when I wrestle, so this ripped off my finger, and my finger was stuck in a gi like this. So, anyways, I just hit it on the desk, and that really hurt. Anyways, once we have a good inventory, right? Let's get back to the stuff. Once we get done with a good inventory, then we can start hitting commands individually. Individual commands are fine for administration. Like somebody needs to change something, somebody needs to reboot a set of servers, you need to run a check, like a little report on servers. Ad hoc commands are okay for that. You just run a little quick uptime against the system, make sure all your systems report back. That's a valid method of testing quick things. But it's not why we use Ansible. It's not why we have, like I was joking around about the cult of Ansible. The reason there's a big cult behind Ansible is once you use it, you go, that's what it does? Oh, wow, that's what I want, like, to focus on so that my career can be Ansible and Netflix as opposed to just, like, bash coding everything. There's nothing wrong with bash coding. It's just you're going to find limitations to it, right? You're going to find that you can't do all the things you want to do. And then there's playbooks, right? So we talked about playbook testing and writing out why we actually use a tool like Ansible and where we actually go with it and all that kind of stuff. So that was last week's stuff. Then we did some labs and we took some notes and we did a project. There's a project that's due if you're doing the actual course. People that aren't doing the course, do whatever you want. You don't need to worry about that. Oh, you know what? I'm going to turn this dark reader back on too. Hold on. Dark reader back on. Because sometimes things get a little too bright in the background. So anyways, that's kind of like how I run through the beginning of the course. We kind of talk through a little bit of that stuff. For people that got here a little later, I'm just kind of going through the Unit 15 stuff for later today. We will do a meeting in the Discord, which is free. Anybody can come to it. We'll talk about the same stuff. We'll go through the lab and all that kind of stuff. I'm just kind of reviewing it so I have it fresh when I go to talk to them because I put this together last year. So this week, we're going to talk about Six Sigma and visualizing data, right, and visual parts of data. So Six Sigma is how do we improve processes? How do we keep track of things? How do we look for differences in output of systems and processes? Everything we do in computer science, right? If you go all the way back to computer science, everything is either input, process, or output. And thanks for that gifted sub. Never fear. Hopefully anybody who gets it doesn't have to watch ads for a month. That's always nice. So after Six Sigma, right? After we set up the way that we kind of control processes, if you will. There's a lot to Six Sigma. I kind of want to do like a whole thing on it so everybody can go get their white belts if they want, because that's a fine thing to have on a resume. And it's a fine thing to have on your resume if you're a systems engineer, or if you're a network engineer, or if you're like a project manager, or if you're a deep in embedded kernel systems engineer. Like, understanding process improvement is going to be valuable to you across any discipline of systems administration, engineering, architecture. Like, the idea that, like, I know that a system works and then I know where I can make it better. I can't think of anywhere where I would be like, oh, Six Sigma, I don't want this guy on my team. Like, I can't think of any single one of those where that wouldn't be like a positive, a net benefit to most people. So anyway, so we talk a little bit about Six Sigma, and there's a discussion post on it, and then we've got visual data. Also, by the way, some of you are like, well, Scott, this is cool and all, but I don't have these slides. Where would I go? Well, we have the course right here. So this is week 15 of the course, which is like engineering troubleshooting. So if some of you are like, well, hey, can I get that lab? Can I get what you're talking about? It's right here. This is the stuff. So there it is there on the Twitch side. There it is there on the YouTube side. So you guys got it. You can now see all the stuff that we're kind of looking at here individually, okay? All right, so where am I at here? Oh, back to this. So, this week we do those things. We take notes. We get into the lab environment. Project check, how's the project going for you? Are you working through the actual course? People that do finish the course get a cool little certificate. And, you can put it on your resume. And then we also have a validation checker. Some of you guys know about this. Built into, where's our course? Hold on. In here. There's actually a little, there's a little thing here that verifies. Give that a second there. Hopefully that comes up. All right, give it a second. Sometimes the page takes a little bit because it's behind CloudFormation. Once it recaches, then it all works. It's just a little bit of a... I thought we had fixed that, but apparently there's still a caching error. Hold on. Because normally you set the CloudFront to cache. Yeah, there we go. It shouldn't do it again. Well, it shouldn't. The origin's definitely up. Hey Trevor, how's it going? Hold on. There it is. And then we would put in like me, and then you would have like a validation that I had done. Yeah, again, that's normally this pops right up. All right, we'll worry about that later. But the point is, for people that want that, they can have a little certificate if they actually do the course. All right, so topics of discussion for this week are, again, troubleshooting. So we talk about some concepts. What is an incident versus like a problem? And I kind of use what's called ITIL for this definition. Incidents are something's wrong with your system. You got to get the system back to working the way it was. Problems are systemic to the system, meaning the system or the engine is wrong in some way, and we need to go fix that so that the incidents don't keep occurring. A way to think of this would be if you were on a road trip. Incidents would be like you get a flat tire. We're not really concerned with why the tire got flat. We need to get the tire off the car and get a new tire on the car and get the car rolling down the road. That's kind of like what an incident is. Now, a problem would be if like every 5 miles the tire just blows up again. Well, now we got to figure out, are we like overinflating the tire? Is the tire scraping on something? Is there like there's all these other things that could be systemic to the system, and they're causing incidents, right? So another way to think of this from like an administrator or an operator, if I'm running systems, incidents are things that keep me up at night. Incidents are things that like call me out at the weird hours. Problems are things that I work on when I'm in the office then later, right? Like an incident might happen, and then an after action review would find the problem because it's the second time the incident's happened, right? Does that kind of make sense? So again, incidents are discrete actions, problems are chronic over time, all right? If you think of it as acute and chronic in like a medical sense, right? Then we talk a little bit about administrative troubleshooting versus engineering troubleshooting. There is a difference. Administrative troubleshooting is focused on getting the system back running, whereas we knew that the system worked at one point, right? Like if an administrator is working on a system and then the system stops working, it's reasonable to assume that if we fix whatever changed, that the system will just keep working the way it did. Administration isn't about going and rewriting the config file. That's super weird. Like if you're that deep in the weeds, you're probably not getting something back working that night. Whereas engineering troubleshooting is a lot of times we're building something from brand new. We are trying to add something into a process that's going to be repeatable as like a CI/CD pipeline or something, and the engineering troubleshooting is going to sometimes be something that has never worked before. We're making it work for the first time. So there is a difference between administrative type troubleshooting and engineering type troubleshooting. We talk about administrative troubleshooting in the sense of like the normal problem troubleshooting steps. We talk about it in like what we call walking the OSI model and symptom diagnosis solution type models. There's a bunch of models for that. There's a thing called React. We'll talk about the React model. But then the engineering troubleshooting is a little different. It's like failure modes and effects analysis, which is like before we build something. Six Sigma or total quality management is during the operation of things. How do we tune in the individual processes to get what we need? And then post-mortem is like after projects are done. Some people call these after action reviews, or a lot of times post-mortem are done after projects. So it's not exactly engineering, but it's still kind of the same concept. Cuddlingus, hopefully it's good. Hopefully my thing doesn't think. Yeah, I'm glad it said cuddling us and not the other thing that it could have said there. So those are our topics of discussion for week 15. Again, I'm just kind of like reviewing this. This is one of these things like I'm kind of just brainstorming what I'm going to talk about in the session in a few hours. So, by the way, for people that are interested, there are a bunch of events coming up in our Discord here. So let me move this over here a little bit. If you're ever in Discord, you're welcome to hang out in ours. We're almost at 4,100 people, by the way, which is kind of cool. There's a study group today in about 2 hours, so that's about 2 hours for me. well, 2 hours for you guys too. I'm just saying in your Discord, it'll show you in your time. Here's the Linux admin course. That's in about, I don't know, that's like 6 or 7 hours from now, right? So that's a while. Oh yeah, Boris, you're talking about when my brother comes to talk? Yeah, he's done it a few times before, and people really enjoy his talks. Then we got an admin study group, and then we're starting to. One of the main reasons I go live in general, guys, is to tell you guys about this stuff. Like, you know, I don't have to stream, right? Like I'm an engineer and a college professor, so like I don't have to stream. But the reason I tell you guys about this is because we do have a pretty good little size community, and I want you guys to come to it and find out that there's a pretty fun set of things that we can do around Linux and systems and people that are trying to get you into this field and that kind of stuff. One thing about that, on August 8th, 9th, and 10th, it's kind of, so real quick, back up. The time that we started the group, it was about 11 years ago, but we don't know exactly when. So we just went ahead and said August, like beginning of August, because that's also when we started 6 years ago on Discord. So we're just like, we'll just call the group started in August, right? So it's our 11th year as a group and 6 years on Discord, right? So we're going to have the pregame is going to be on Friday night on the 8th. We're just going to hang out. I'm probably going to have different people from the group pop up and talk and tell you guys about, I don't know, whatever kind of fun stuff they want to talk about. Maybe how they met up with other people. Maybe if they want to share some pictures or something. I don't know. We'll let people talk on there. And then when we start the conference on the 9th, on that Saturday, these look really low numbers, guys. We had 1,000 people last year in the Discord when we did this, and we had a few hundred people show up. So this was pretty popular. I'm going to start with my why engineering talk. So I have a talk that kind of does that, and I have to revamp the whole talk and add a whole bunch more to it. But like, why do we do engineering? Why have we chosen engineering? Why aren't we doctors or lawyers or any of these other things that we probably could have done? Why engineering as a hobby and as a I don't know, way of life, I guess, but also as a profession, right? Way that we can make money. So why engineering is kind of my talk on that, and I can show you guys a little rundown of that here. Probably in the next few weeks, I'll kind of show it to you before I actually run it live. Then my brother Tom's going to come. He's a data analytics guy. He does data analyst work for a large insurance agency. He just finished his master's degree a few months ago in that. And he's been doing that for a while, and he's pretty good at it. Last year, he came and talked, and he did a really cool... He just pulled a bunch of information from like NFL.com on the season, and he showed a whole bunch of ways of analyzing who was actually the best running back based on not just the team's overall offense, but all the teams that they had played against, to really zero in on who was the running back that was producing the best for the year. It was a really cool little talk that he did last year. Cuddlingus said, "Hey Scoot, do you have any buy me coffee or anything for Discord or stream?" No, I mean there's obviously like Twitch stuff if you want to do that kind of stuff, and then I mean I have the book. I always tell people go buy the book if they want, but like nobody has to buy the book. Hold on, I need to see if this verifies. Yeah, that verified finally for me. So that said I was the course instructor. Yeah, people can buy the book, but you don't have to do that kind of stuff if you don't want. Like if you're just looking for like some way to help, just I guess help out the Discord. We do have, like, I did set it up where there's like a GitHub thing. I don't know, the guys made me do it where people can like donate to GitHub, but I'm not like worried about that or anything. Like I like that people want to help Cuddlingus, but like really at the end of the day, our goal is to get people doing this stuff, right? But I do appreciate it. Obviously, it's always good. So main thing I would tell you if you really want to help out is just make sure people don't have to watch ads in the channel. So that's kind of stuff. Hold on real quick. What else did I miss? How do you counter people that say IT engineering isn't real engineering, like mechanical, electrical, civil? Well, IO fault, that's, in some ways that's true, right? In some ways, people are just out there changing things and pushing buttons until stuff works. But we can apply real engineering principles to this stuff, right? IO fault. I mean, in some way, like I'm a classically trained, I guess if in that kind of sense, I'm a classically trained process engineer, even though I've been in Linux and systems for a long time and network engineering. Yeah, I mean, if you're not building stuff from scratch, let's say, but you are still implementing process design, right? You are still taking known systems and modifying them and changing what they need. I tell people all the time, if we didn't need engineers, like if this stuff just worked out of the box, the salesperson would set it up and they wouldn't need engineers. They need engineers to configure the stuff and get it set up for the individual components. In fact, there's a whole branch. One of our guys came and talked. He works at Red Hat. His name's Ashton Davis. He came and talked to you guys one time about pre-sales engineering. This whole vast thing that's somewhere between sales and somewhere between engineering. And what these guys do is they set up the system and kind of get it ready for the scope of what they're going to go do. So they're somewhere in between. And thank you, anonymous gifter. Hopefully that's somebody we know probably, but hopefully if you get one of those gifted subs, you don't have to watch any ads for a while. So hopefully that's useful to you as well. But IO I guess there's always real criticisms like that. But I mean, I know people that are electrical engineers that don't ever do anything except go out and look at like wireless site surveys. So, you know, there's a wireless site survey is also an engineering practice, by the way. But my point is, you could just do it with all tools, right? Because the argument is, well, you're just using tools. Well, I would argue if you don't build every OS from scratch ever, you're just using tools in some way anyways, right? Like a lot of times, like even Linux engineering, unless you're building the kernel yourself every time, you're kind of using other people's tools. I was even thinking about this the other day with like a security engineer who pointed out, he's like, hey, all I do is use smarter people's tools. It's like, that doesn't mean he's not an engineer. He's still penetration testing and looking at systems, and he has to understand. I tell people all the time, admins set stuff up, engineers understand the why. But we do the same work a lot of the times. It's just engineers tend to make a little more. So yeah, I would tell you that like the application of the rigors of engineering to build things can be applied even in just IT. And that's one of the things Six Sigma is really good for, is it's a process engineering thing. So, wait, Culling, you said you just want to give a shout out that you got your first offer for a Linux admin yesterday, large part. Oh, that's awesome, man. So I was just showing the wife yesterday because somebody popped in Discord. I don't know if it was you, Cuddle, because I know everybody's got different names between here and Discord, and they were saying that they had just gotten a job. And I told the wife, I was like, this is why we do it right here. So that's awesome, man. That is really awesome. So even if you're using tools to engineering a solution, and yeah, Boris, that's the point. Like, yeah, like let's say you were just setting up Linux systems, but you were setting up Linux systems into like a high performance compute cluster. You still had to understand where those systems were going. Anybody else could come along and push buttons and build 20 Linux boxes, and with DHCP they could get them on the network and they'd all be talking. But you've assigned roles and inventories and tasks and you know, you've done all these other things, which are I have a drawing of it. It's not a very good drawing, but it basically shows how like admins are doing these tasks down here, keeping the lights on, keeping the systems up. Engineers are doing these tasks here, which is like building systems and doing stuff, but they're also doing some of the admin tasks, so it's a little bit wider bar. And then architects are up here planning stuff, but they sometimes do some of the engineering stuff in that they actually, I know architects that build stuff still. So it's like, it's this weird, there's this like overlap between typically like admin, engineer, architect type level work. And I call myself an engineer, but I do architect work all the time. I draw stuff up. I drew up stuff for a large, so one of my buddies left the Space Force recently. So one of the guys is coming to talk to us that's still in the Space Force, this one. And then another guy that I know just got out of the Space Force, right? And he asked me, he's like, Scott, I'm going to set up a SCIF where I live. So that's like a secure compartmentalized information facility. What might a quick overview? Oh, I did on stream for some of you guys, right? Some of you guys were on stream when I did this. It was what like an HPC cluster at like the bare minimum might look like. And I told him like I could put something together for like a few $1,000s, and I gave him that separate. But then the one that we did was probably about 100K. And then the one that he'll probably settle on near the end will probably be closer to like $1 million. But I gave him, I showed it on stream. If you guys, where did I, hold on. I'll just pull it up here. This was like the reference architecture from NIST 800-223, right? And then this was the hardware, the software. We did this all on stream a while back. What the build out would look like, right? And you might say, Scott, that looks a lot like architecture work. Yeah, I'm still just an engineer. Like, I mean, it's all security, compliance, how we would do it, what the training might look like, you know, for the on-site support people, which might end up being me too. and then some of these other things. And this was just something I did for a friend, like off to the side, right? And I don't know where I was going with that, except yeah, engineering is engineering, guys. Don't let anybody tell you it's not real engineering just because it's not one of like the classical ones. I mean, there's one that's coming out right now that's like people are arguing about it. Like, is prompt engineering engineering? And it's like, look, man, I can't make some of those prompts do some of that stuff other people can. If I spent some time with it, maybe, but there are engineering concepts being applied to how people are interacting with these AI chats and that kind of stuff. So in some ways, there is an engineering there. Early on, it might just be people messing around, but over time, there's going to be codified engineering rules that are going to be used to that to make it work pretty well. So anyway, so yeah, I appreciate the anonymous gifter, and then hopefully, that's super awesome though that Cuddlingus got a job. That's going to be awesome. Now, look, there's a lot of things that are going to happen, Cuddlingus. They're going to get you in the environment. You're going to get set up. You're going to start getting tickets. You're going to work through stuff. But I think all in all, it's one of these things where you have a good base of like understanding of the system. You're going to figure a lot of that stuff out. And then I would just tell you, other than that, get a good note program and make sure you're taking notes of things. You know, people's names, who you're working with, you know, points of contact. That's all good stuff in the business world in general. But I'm saying then also, you know, what you're seeing in the systems, you know, if there's things that you need to come to later and all kinds of that stuff. Zorgel said, sometimes engineering requires being an effective communicator. Good word, Dark. 100%. Zorgel, everything we do comes down to, like as an engineer, unless you're the one that's going to work on it forever, you have to be able to hand it off to other people. One of the things I always tell you guys this: your documentation of a system, your documentation of what you've done, your write-ups, your what goes into your wiki, you do whatever you want with that as an engineer. Because, by the way, management doesn't understand what the fuck you do anyways. But you are betting your weekend. You are betting your weekend and your time off, and you're not getting called out by a junior engineer on how well you write that doc. That's it. That's all there is to it. Because if somebody gets to some step and it's like, and then log into the host server, but there's like 3 different clusters and the host server is different for each one, and you don't clarify, and this is how you find it for the cluster you're in or something like that. If you don't do that, you just assume the host server because they should know, you're getting called. There goes your Friday night or whatever, because that's all. That's how this works, guys, right? Like so there is some stuff as far as like how you communicate, because it's all magic until it's not, right? Until the rubber meets the road and somebody needs to actually run your docs. Yeah. That's Boris. That's one of my favorite quotes ever. You said if you can't explain it, you don't understand it. There was a guy, Edwards Deming, who, by the way, is kind of the father of Six Sigma, and he said, if you can't break everything you do down as a process, you don't know what you're doing. Like if you're like, well, okay, so this is how I got this little tool here. This tool's a little back scratcher, and we'll see the way I use it is I kind of pull it out, and then I kind of like do, you know, and then people would be like, this guy doesn't even know what he's fucking talking about. He needs to be able to describe the things he does in steps to be able to get that. Yeah, that was an Edwards Deming quote, which he's gonna come up in the talk here a little bit. I don't know if we hit him too hard, but he's definitely part of some of this talking and stuff that we do. So yeah, anyway, write my docs so the janitor can do it in case I get hit by a bus. Yeah, like I tell people, I try to document stuff such that you could just replace me. Because if you replace me, then I'll just go wander off and do something else. I tell you guys all the time, I'm waiting for the guy to knock me off the top so I can go do something else. But that's mostly just me kidding. All right, so here's our topics of discussion for Unit 15, which is coming up later today. We're just kind of reviewing it now. But let's talk about some troubleshooting concepts. Troubleshooting and engineering in general does boil down to, at the end of the day, the scientific method. So we observe something, we form a hypothesis, we experiment, we test our assumptions, we come to a conclusion, and then we iterate over these if we don't understand. Now, observation breaks down into what we call instruments. A lot of times we call things instruments and metrics, right? An instrument is the thing that you're using to do the measure, right? So in this case, let's say I thought my Linux box wasn't working right. So then I ping, right? And I ping Google. And I just ping, maybe I do like I'm smart about it, I do like a ping-C5 or something. I only want to see 5 pings over there. Now let me show you guys something. There's a whole bunch of measurements in what we just did. If the measurement that I wanted to test was so maybe the instrument I use, the instrument I used was the ping command. But the metric I might use is simply how many responses did I get. And in this case, I sent out 5 echo requests and I got 5 echo replies back. Does everybody gets that, right? That's echo ICMP out, ICMP back in, right? 5. So in this measure, if I had 1,000 servers and I did this across all 1,000 servers, I just did like a little ping check. Maybe I run it with Ansible. I get my response back. I see that all 1,000 machines have all 5 back. Could I say all the servers are good? By that measure, 100%. But then I add a new metric, a new measurement, because again, for that one, I just have everything the same. Everything's the same. I come over here, and now I've got this time measurement. And my times here, let's make this a little bigger so it's easier to see. So I've got a 24.5, a 22, a 25, a 21.8, and a 22. What if I then have another metric that I want to track, and I'm still only going to go over 5, so that's not a very big sample, but I'm going to look for variability within it, right? Then I go take all these numbers, and I average them up. Does everybody know how I would average them up? I would go get a little calculator program like this. By the way, we would automate this, and but let's say we were just doing this here. We would go here, and I'd go 24.5 plus 22.9 plus 25.1 plus 21.8 plus 22.7 divided by 5. And that would be my mean, right? That would be my mean. We could find our median and our mode, but in a small sample like this, we don't care about median and mode. Mode is when we find the number that shows up the most. We're not going to have a mode here because it's too small. And median would be the middle number when we put them all in order, right? And if there's an even number of numbers, it would be the number in between those two numbers, right? We don't care about that because it's such a small little variability. But where I'm going with it then is then we can start to from here. And by the way, as we get more numbers, this becomes easier to find. We start to find the standard deviation from the mean on any one of these, right? And then we start to go and calculate. There's some little curves, and this is all stuff from Six Sigma, right? But what I'm saying is what we would do then is from across those 1,000 servers, we would look for the ones that are having variability high and low. And then we would maybe find out of those 1,000 servers, like 20 servers that have this strange variability. They have that same average as us, but some are down in like the 19 and some are up in like the 27 range. So they've got these wider ranges within that same mean. Does that kind of start to make sense? So then I start to add these other variables within my instrumentation. And then what happens is I find that I start to drill down in and those 20 machines are on the same subnet. Now I start to have something to look at, right? And all this stuff, all this scientific method stuff is using tools and then figuring out things from those tools. That's literally all it is. And to that point, like we were talking earlier, like people that say, oh, this isn't real engineering because you're just setting tools up. It doesn't have to be real engineering. I could have just pinged and said they're all good. But what I did was I started to apply engineering principles to this, right? That's going to come up. Some of that stuff's going to come up later in the failure modes and effects analysis. But what I wanted to show you guys is like observation deals with the instrumentation. Now, how much do I rely or how much do I trust this ping tool? Can I do only 5 samples or do I need 100 samples before I do some of that stuff? So there's a whole bunch of stuff we can do with that. But instrumentation and metrics. Then we start to form a hypothesis, right? And we formulate possible reasons for a problem, right? Like what's the reasons it could be. Then we test it and we change different variables or we test conditions and then we have a control, something that doesn't change. This is a thing that I often tell you guys about ceteris paribus. Ceteris paribus is the thing called all other things being held equal, right? Ceteris paribus. It's typically an economics term, but it just is Latin, so anybody can use it. And it means that like there's all these other variables that could be happening in a system, but we try to hold them all equal as we test whatever we're testing, right? And then analyze results to confirm or refute. We're not going to go into null hypotheses and those kind of things, but basically we either accept that the hypothesis was true and then we try to fix it, or we don't, and then we iterate over these. That's the general scientific method, right? And engineers, I tell people all the time, engineers apply more science every day than anybody else because we're applying stuff to real life, right? We're doing real things and gathering real information in. So, all right. So that's scientific method. Practical tips. Documentation. Keep detailed records of all your observations, hypothesis tested, and outcomes. So keep it a good notepad. Have notes. This should be time bound. When did things happen? How long did it take to complete? That kind of stuff. When something was observed and by whom, or what system it's on, for sure, even if you don't have the individual person who kicked it off or whatever. Teamwork, involve people with different perspectives and expertise. That's somewhat true. A lot of times in engineering, we're just heads down, but it is good to get other people involved because maybe some people know, the underlying networking that's going on that I might not see, right? So they can look at some other stuff. They can track when things hit a firewall, and then I can start to figure out if more of the latency is internal or external. We can start to really track that stuff down, right? And this sometimes happens. I've worked on systems where our millisecond response times between like our database and our applications have to be under like 2 millisecond response times. And if it starts to get over that, then we immediately are all called in and try to fix it. And so these are things that you need to think about and what level of precision do you need to look at in the system, right? You need to use tools, employ software, diagrams for better visualization and analysis. Again, if I just show people this, they're going to be like, I don't know what that is. So you need to sometimes draw things out, draw what your tests look like, put them in Excalibur, all kinds of stuff like that that's, I think, useful. All right. Where are we at here? Oh, yeah. Iterative approach. Be prepared to revisit steps or hypothesis as new information emerges. So sometimes you got to retest things and you got to go look at stuff again, but make sure you're keeping all of your different information tracked. And there's a lot of tools that help with this. Like, you don't just have to do this stuff and throw it in like Notepad++. You could also, there's all kinds of like scientific tools and different things that'll help you. Sometimes when you're doing research and stuff, I use a tool called Zotero. I really love it because if I'm reading anything on the web and I just hit save, Zotero just saves it for me. And if it can be put into a bibliography, it'll do it for me in whatever format I want too. So that's kind of cool. ROV, how's it going? Hopefully this stuff's useful to you. Thank you for the follow. Understanding data. There's continuous data and discrete data, right? Typically discrete data is ordinal, counting numbers. 1, 2, 3, 4, 5. I put you in order, 1, 2, 3, 4, 5. That's how we can count data. Sometimes it's nominal, so it's simply numeric data. There are 10 of a thing, there are 13 of a thing. But if I were to ordinally count those, the first group would be 1 and 2, right? So there'd be 2 groups, but of maybe 10 and 13 pieces of data or whatever. So that's nominal. And then binary. We know binary is true and false, right? True and false, 1, 0, on, off. That is probably the thing we look at the most in engineering. In fact, some people might argue most all software engineering is the search for ones and zeros, the search for truth, right? Testing things true, testing things false, that kind of stuff. That's different than continuous data. Continuous data is measured in units, and it's like the time of day. We measure it in hours, right? Temperature is measured in degrees, but it's continuous degrees going up and down throughout the day. And then accuracy, that's the trusting your tools collected and the methods. So we were talking about the instrumentation you use, how accurate that instrument has been proven to be in the past. In research, the instrument has to have been proven to be accurate before you can use it again. Like if you're writing a dissertation, I have to use instruments that have already been proven. I can't go through the process of building my own instrument out. That's not really allowed in the academic world. Once you're done, you can use any instrumentation and build whatever new stuff you want. But when you're first doing research and stuff, you can't do that. All right, so anyways, that's understanding data. All right, then let's talk about administrative troubleshooting. So like you've got a set of servers and something's wrong, something's busted. What are we going to look at? Well, one way to do it is 8-dimension problem solving. By the way, problem solving tends to be 6 steps. I'm going to show you the 8, the 7, and the 6 right here. So here's a 8-dimension problem solving method. If you're in a big company or you're working on a multiple input process, the first thing might be to establish a team. Maybe you've got a team that gets stood up specifically for problems. Maybe you've got a bridge call that gets called out for incidents or something. often, especially if you have P levels, like priority levels of alerts, if you have like a P1 severity incident happen, like something production customer facing is down, one of the things that like your bridge team or like your if you have like a NOC, their job may be NOC, Network Operations Center. It may be to stand up a bridge call and get everybody alerted into that bridge call. That's a thing that might happen. Then we got to describe the problem. Typically, that is like right in the title of the meeting or something. You know, this application is down. This application is no longer available for customers, right? That could be a thing. And then that may get broken up later. So it says develop interim containment actions. Maybe we start to break down the problem. So like I just said to customers, but what about internally? Can we internally still get to it? Because that's going to split the way that we look at this. If internal people can still get to the app is up. Now we've got some connectivity problem to the outside, right? That's so we start to break down the components of the thing and look at how it's working. Then it says right here, define and verify root cause. This is always going to be more precise than this description of the problem. Description of the problem is some services down to customers. This is this service on this IP address or on this whatever is no longer serving back TLS, handshakes because the PKI certificate has failed or something. I don't know. Something, right? Something is not happening, but you're really digging in. You're looking at how the calls are happening against a page or against an application, and you're making sure that the data are flowing through the system to a certain point, and now you're really defining what's happening, right? Then you verify permanent corrective actions, right? So you start listing them out and testing them. You implement them, and if it doesn't work, you have to come back and redefine and keep going through this. You spin a little bit here. Then you prevent reoccurrence. Was it a human error or was it a system error, right? Those are the two major types of errors we tend to deal with. And prevent reoccurrence. Did somebody make a fat finger and hit the wrong button? Or did a system fill up, wasn't being monitored, some threshold was crossed and nobody caught it? There's all kinds of things that could be prevented if we were either tracking it or keeping guardrails so that people can't hit the wrong buttons, that kind of stuff. And then you congratulate your team. I mean, I guess we could leave that off. So 1 and 8 are only there if it's a big enough problem, right? But congratulate the team is also after action reviews or post-mortems to make sure that things worked the way that you expect, checking with the team to see if maybe the call-out procedure didn't work well, and that resulted in somebody taking 15 more minutes to get on. Or maybe some team had some a switch. There was a switch over of who was there on call for that weekend, but it never got fed up to the company, so the wrong guy got called out. There's all kinds of things here that will get better if you go back and review them. And this is obviously focused on like a big enterprise. So like the bigger the enterprise, the more of that kind of stuff that's going to kind of happen for you. So you got to think about that. This is the one, this is exactly the one I learned in the military. 7 steps. It's always going to be the same. Identify the problem and its symptoms. Start to define the thing based on what does and doesn't happen, right? Establish a theory of probable cause. So for me, that is testing what I know, testing what I don't know, figuring things out until I can narrow down, like, okay, up here, it was intermittent problems with users logging into the website, whatever our app is, right? Down here, I see that we've got a front-end load balancer, like an ELB, an elastic load balancer through AWS. And it's application, ALB, application load balancer, so it's up at layer 7, doing all this stuff. But, it's going to 7 different back-end interfaces. So I start hitting those interfaces individually, and 4 of them respond well, but 3 of them are just doing some other bullshit. They're not responding. Now I start to see, well, it's not the load balancer's problem. It's not those 4 up there because remember, it's an intermittent problem. It's these 3. Then I go and I start looking at versions and I say, oh, why are they on the old version? This got updated last night. Oh, we didn't roll through all the we can go figure out what caused it later. We know that there's a difference and we know that the ones that are current are working and the old 3 are not. Now we're gonna test our theory to determine the cause. Maybe we do a little more testing, get some of the developers in. Maybe we cut that application load balancer to only point to those other 4, and then we look at what's going on with those 3, right? So we test our theory and we determine that's really the problem. We establish a plan for resolving the problem. Well, let's delete these 3 EC2 instances or whatever and bring them back up new with the new stuff. Obviously, our deployment problem, there's a deploy problem, but that's fine. We figure that out later. Let's get this back up. Implement the solution. So fix that, point it at all 7 again. Boom, it's up. Verify our functionality. No more intermittent problems. I test it, 30 times. My connections go everywhere. I'm watching on the logs to make sure that I'm hitting all 7 instances. Cool, whatever. This might sound more of like what an SRE type person might do, but this is what our job is as engineers. I can be a Linux engineer and be all these other things, guys. That's going to be your career, right? But anyways, verify full functionality. We fix the thing, and then document findings, actions, and outcomes. So we document what happened. We give some timelines. I was called out. I found this thing. That helps us to figure out what our mean time to resolve and our mean time to detect and all those things were. But then, and again, it's not necessarily that we're pointing fingers. We just don't want this to happen again. We let the deployment team, whoever did the work the day before, know that, hey, you only got 4 of your systems, and these last 3, they failed as of last night because they were pushing their, they weren't able to push over to the new database schema, and they filled up and it crashed the EC2 instance. I don't know. Whatever the problem is, we found what was actually having the incident. We fixed the incident, and then we need to go figure out how deployments work in the future. And you find out that somebody had hard-coded from an earlier assumption that there was only going to be 4 boxes. And there you go. Boom. They fix that. It always tests then when it deploys how many EC2 instances are in the, what do they call that? It's like a host group or whatever that is. Can't remember what that's called in AWS, but in that thing, and then they deploy it and it works that all. So good. All right. So that's another way of doing troubleshooting, right? But I would tell you, know these, right? You don't have to know how to do every single thing, but you should have a way to kind of walk through these. And I would have these in my notes, and then I would be like, what's the problem? And I would give a high-level definition of the problem. What do I know? Well, these boxes are all up and running, and they're establishing API call. My API calls into them work. They're open on port 5000 like I expect on the back end of the load balancer. I would start to knock out things that are and aren't good and are and aren't true in the system. And I'm always looking for what I call aberrant. Did I get the word right? Hold on. Things stopped working. I said aberrant. There we go. I wanted to make sure it got the word right. Yeah, I'm looking for things that are out of the ordinary. And then I start to write those down, and I keep track of them. All right. Here's another way. This is a very short one. This one's only 6 steps, but it's the same thing. Identify the problem. Establish a theory of probable cause. So you're testing things and you're figuring stuff out. Test your theories to determine the cause. And then you go with whatever one you think is the next. So establish a plan to solve and implement it. So 4 is 1 step, but in the 7th step, 4 is broken out. 5, verify full functionality, and if applicable, implement preventative measures. So make sure it doesn't happen again. And then the last one is document your findings, actions, and outcomes, which is the same thing as stepping back, figuring out what went well, what didn't go well, all those kind of things. All right. Very similar to this one. The React one, this one comes from Microsoft, but I actually really like this one. I constantly show this one. It's easy to remember. React, research, engage, adjust. This is the first half. This is the fixing part. So research, go find more information, ask probing questions. Actually, that's over here. Research is what do you do first when you get the trouble ticket or you get the incident. Sometimes these have to be squished together because it's a high priority. But if you have time, research, engage, ask for problem description. If you're running the call, you're making sure that people are communicating on the call and you're moving stuff forward. There's a really good methodology. There's a whole troubleshooting process called Kepner-Trago where they'll come out and train people. Very expensive, but if your organization's got money, they will teach you how to keep one of these meetings moving forward. I would tell you at the slightest, if you're not good at running meetings, go get into Toastmasters. So I talked to some of you guys, and some of you guys have done Toastmasters with us. Not with us, but different people in our group have done Toastmasters. I grew up doing Toastmasters. They will teach you how to run a meeting. They will teach you what's called parliamentary procedure. That's very useful for running a meeting. If you're just somebody you might think oh, I'm an engineer, I don't need to know that stuff. You don't, but it couldn't hurt your career any. But engage, ask clarifying questions. And then with your adjusting, you're going to change settings, reinstall hardware, reinstall drivers. Whatever the fix is happens here. So in an organization, there's going to be some change management and there's going to be some approvals and some other stuff. But the point is, after you've engaged and asked questions and you've done the things, you're going to adjust whatever it is within your system, within the processes defined by your organization. You don't just go wild, wild west shooting off pew, 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 and fucking fix everything that way. That's not a good way to run a company or build stuff. Make sure you go through your change management process, adjust what you need to, and then help to solidify it down, right? Then configure says ensure standards are enforced and update standards as needed. So if something went wrong to allow this to happen, either by a user or a system, if it's a user, you got to correct the user, you got to train the users, you got to put what we call guardrails in place so users can't do dumb stuff. Sometimes that means removing permissions, guys. And if it's admins, maybe you got to lose the admin. Because, like, admin's a huge responsibility. I told you guys, like, I sit around sometimes and I think, like, I could take all this down. I could just do a reboot on everything. I'm not going to do it, but the power you have as, like, root in a system and then you have automation to hit everything, you cost a company millions of dollars a day sometimes. That's a huge responsibility. So anyways, my point is if your admins don't take that responsibility heavy, like the way they should, it's very possible they shouldn't be admins. They should be like running a car wash or something. I don't know. I've been watching Breaking Bad and they just bought the car wash again. That's kind of funny. And then update standards as needed. So again, if you don't tell people the standards, there's an old saying, if policy isn't enforced, practice becomes policy. So there's an old saying about that where if I don't tell the people, well, one, if I don't tell you what the policies are, and then if somebody's training new people and just like, well, that's the way we're supposed to do it, but this is the way we actually do it, and your policy isn't enforced, then the practice that they just taught them is going to become the policy. So that's an old saying in, I guess, in management, which I've never been a manager, but there you go. And then take note. What was the problem? What was the cause? What was the solution? Who were the principals? So those are the people involved, the stakeholders, the people who had to do the change and the fix and that kind of stuff. And then try to ensure that this doesn't happen again. This is a good methodology for troubleshooting, though. It's called React. It does come from Microsoft, but we can't fault them. I mean, they did build Samba, didn't they? All right. This one's probably been the most productive for me in my career, is stepping through the OSI model. The OSI model is from the ISO, which is the International Standards Organization, but it's the OSI, which is the Open Systems Interconnect model. It's the model that we use for two reasons. One, we use it to teach networking to people, and two, we use it to ensure modularity in networking, right? Those are the two major uses for the model. But the model is super simple, and I have a whole talk on it separate, and this is what I've been teaching in college for the last 17 years. But application, presentation, session, transport, network, data link, physical, that's 7 to 1. Some people like to say all people seem to need data processing. I don't know. I think if you just learn the model, you don't have to have all those funny little, whatever those are called. Not anagrams, but there's some name for them. Mnemonic devices, is that right? I don't know. Mnemonic devices, I think. Yeah. OSI is goated. Yeah. So, but thinking of it like this from the physical, and then there's please do not throw sausage pizza away. That's 1 to 7. But the way that I think of this is, how is something working or not working? So I've often joked, right, that you would call a network engineer and you would say, hey, I can't get to this server. And the network engineer would go, hey, that server is 10.3.31.11. And you go, yep. And he goes, well, I just pinged it, and he hangs up on you. Because network layer right here, this is where IP addressing occurs. And if your device is responding on the right IP address, there's all kinds of other problems that could happen. If you don't have a good IP address management, what we call IPAM, if you don't have a good IPAM, maybe somebody allocated that same IP address and now you've got a conflict. That's a problem. But let's just say that's not the thing. They pinged it. So think about it. If this is working right here, if my IP address is working on a device, that's a logical address for us to get over there, right? Well, do I need to go check to make sure that the thing has a network connection like plugged in? Like if it was wireless, would I need to go make sure that the wireless was blinking green? No. Would I need to ensure that the wireless adapter or even the wired adapter was plugged in, right? Would I need to make sure that it is the right type of connection and like not fiber? No, because I got a ping, right? So this is good. The data link used to, I tell people, it was going to be broken up into media access control and logical link control. So there were two methods. Data link layer almost got chopped into logical link control and media access control. So logical link control is how do we connect into the physical layer and make sure that we're following the rules of the road, if you will, right? Like are we using some type of Ethernet frames, and we're doing carrier sense multiple access with collision detection. So we're doing some type of contention based, or are we doing some type of polling based where you can only talk if you have the talking stick or the token or whatever, right? There's all these different methods for link control and how we access. Well, so that's actually, that's media access control. And then link control is what are the ways that we're actually encoding the bits down? Are we using Manchester encoding schemes? Are we doing all these different types of things, right? And then network layer up here. This is obviously you've got your IP situation correct. You're properly routing within your networks and that kind of stuff. But again, if you call a network engineer and they can ping a box and they hang up on you, it was your own damn fault because you should have pinged the box first, right? So anyways, somebody said, do you do these more for viewers or more as source of personal review that also happens to be shared? Seems like it would be great for relearning. So I think I'm just going to say you're going for African Boy as your name. So, this is kind of a review for me, but this is going to be us talking later today, and that is not recorded. That's just down in the Discord. That's just for us, and I'm just kind of reviewing it. This is actually Unit 15, so there is a recording of this on YouTube as well. But no, I'm just brain dumping right now, just kind of thinking through what I want to talk about. Some of the things I've said, look, I've already been talking for an hour, but when I meet up with the group, we only hang out for an hour. So I probably won't be talking this long. So some of this stuff will be cut out, but I'm just kind of brain dumping on you guys. So hopefully it's good information, but this is recorded as Unit 15 it's in one of my playlists. It's called the Linux Systems Administrator course. This is Unit 15. So I've got a different recording of me going over the same slide deck. Also, these slides come from another talk that I did called my networking primer. And the networking primer is just like 3 hours of this, where I talk through this and this right here. So kind of breaking down how things work for you kinds of stuff. No, it's fine. No, we're live, right? So I don't mind telling you guys. I'm just kind of hanging out. No, you're not interrupting. If you guys have a question, you can always do !ask as well, and that will interrupt me. I assure you it will interrupt me, but I think it's funny. So here, I'll show you guys.
I can answer that for money.
That makes me laugh to no end. All right. What's going on over here? So this is kind of for me, and also this is for you guys, right? Like the main reason I even go live. So the question on YouTube was like am I just kind of brain dumping? Yeah, these are up there. These are recorded on YouTube. But also the reason I even go live or anything is to tell you guys that we've got a group. We meet down in Discord. It is the Professional Linux Users Group. The goal is to take people that do Linux for fun and hobbyists, which we're all hobbyists. We all do this stuff for fun. But showing you how to get into this professionally. That's the goal. Getting you guys to, kind of bridge that gap. Because, like, a lot of times, trust me, I'm in the same boat, guys. I do not want to fucking talk to people. Like, on the average day, if you just left me down in a basement or a server room, I'd be perfectly happy. But over the years, especially as I've done this more and more, they've pulled me up more into the light. And I'm like, like trying to hide in my little basement. And they make you interact with people more. So since that kind of is the case, I try to show you guys like how we interact with the business. So if you ever go and do the other parts of the course and stuff, you'll see like it's how meetings are run, and it's all these other interactions. But we're focusing on being Linux engineers, right? Linux admins, Linux engineers. This is networking, but like everything we do touches networks, right? Like we're pinging devices, we're looking at like how is our system resolving where something is coming from, how does that behave within our system? And then if we really need to dig down into like the technical parts of that, I've got labs and stuff up on Killer Coda that show you, okay, we resolve DNS after we resolve local host names. Well, why is that important to understand? Why is our local host file maybe more critical than like a DNS even in the organization? Well, a lot of that stuff I tell you guys is about control. If I'm running a cluster like an Oracle cluster or a Werewolf cluster or something in an organization, I don't know. I don't always control DNS. In fact, I would say in the enterprise, let me think. I've never controlled DNS in an organization at the enterprise level. Sometimes within my own little clusters, I control DNS internally. But the reason I say that, you say, well, why would you say that, Scott? Well, because would I then trust my cluster to DNS if I don't control DNS? No. I would trust my individual host file, which is actually true a lot of the times. In fact, some of our tooling, some of the stuff that we use here, like when we use the tool like Werewolf or something. What happened here? Oh no. Here. I don't even know what's going on there. Werewolf uses flat files within its configuration, even though it runs its own local DNS server. It's still, even though it's running DHCP and DNS, it also still has flat files just in case. And that's just a cluster manager that we run. All right, anyway, so back to here. Stepping through the OSI model, we can find things out about how a system's responding. An example that I just kind of showed there was if I hear that a server is down, right? They tell me a server is not working. So I say, okay, I'll go over to Rocky 19. Well, I just jumped into it over SSH. So by IP address, by name resolution, and by port 22, like that box is up. I just connected. But let's say that maybe it wasn't up like that, so I had to get a console connection to it, meaning I had to use some out of channel way of getting over there. So I had to go to like Rocky 19 like this. And this is how I got into them, right over here. And I think I might have access to them this way. Maybe. Yeah, so now I'm in them here. And maybe I have to like ping. Well, what might I want to know? Like if he wasn't responding, if I'm going to do it over here just so you guys can see. But let's say I was connected over there. And what if I did like an IP-BR ADDR? So now I see here's his Ethernet 192.168.200.69. That's his address. And he's got a /24. So I see that he's got an IP address, but maybe he's not getting out. So maybe I do route, or maybe I do IPR, which is also the same thing. And I see that if I want to ping something, so 192.168.201 or 200 on this network is going to go out ETH0. Maybe I want to make sure that I can ping something out there. So then I happen to know that 192.168.200.1 is my gateway, so I can hit my gateway. But then I say, well, maybe I know my next hop in my environment. I just happen to know the internal next hop, and I can get there. So I'm mapping in my head that I can get out. And then maybe I try all the way out to Google like this, right? And something just happened there. I used a short name for Google. I used like a human readable Google name. But my system went all the way down, right? It went all the way down and resolved Google to an IP address. So that's DNS all the way through. If I were to look over here, this happened all the way from here down up to here. That's DNS wherever it resolved DNS from out in the world and came all the way back to me. That means my system's connecting out. All layer 1 through 7 is working as far as that goes for now. If something else is wrong, I got to go figure out where it's at. But the point is, I can ping all the way out. So there's a lot of information that's happening right here in just a simple little ping, if you know what you're reading. If ping fails, but I still resolve the name, then that means that wherever my resolver is, if it's local, maybe I resolve locally internal to my company, but I couldn't get out past like some firewall or gateway or something from my network. There's all kinds of things that I can start to test. And I can say, well, where did this resolve? Well, my resolution for Google came from here. I use 8.8.8.8. That's out in the world. That's one of Google's servers, right? If that was 192.168.11.1, which is my internal DNS result, was one of my internal DNS resolvers, then and I was able to resolve but not get out to Google, that's still probably like do you guys see how like my internal flow of networking is completely fine? It's when I try to get my system to get that connection out, and that's where I would start to look. So there's my point in all this troubleshooting is, if you understand where the data are flowing and you understand how the data are flowing, then you can start to figure out where things are broken. And this will tremendously help you. And guys ask me all the time. It's in our Discord right here. They'll ask me, like when I do networking stuff, so we do there's networking topic stuff. People ask me, how much do I need to know about networking? Or do I even need to know about networking as a Linux engineer? And I go, yeah. Because I've never once, not in my entire career, worked on a Linux server that was not on a network. Never once. I've built Linux servers that were off, like, connected networks from the world. They were off on their own, but they're always connected to some network somewhere. Anyways, there's all this stuff. And one of the things I always show you guys, I'll give you guys this link, because I really do like this book. It's a free read book. It's actually down here in there's a thing called Beginner Start here in our Discord. And it is right. Here's all the books, and here's that playlist I was talking about earlier. Do I not have it right here? Yeah, I'll find it. It's over here in networking for sure. Because I used to do these little topics in networking. I was always doing like little chats. Threads, they call them in Discord. Let me find one real quick. Yeah, here's the red book. I think the red book from IBM is like one of the best things anybody can show you. Because while it's still dated, it's a little bit dated, it still has just one of the best. I'll pull it up here real quick for you guys. It's just got one of the best, like, first few hundred pages to start with. So people ask, so again, it's from like 2006, so it's a little dated, but right here, come right here. I tell people all the time that you should know probably the first 140 pages of it from like a Linux admin standpoint. And I think that you would be pretty solid. You don't need to know, like, when it starts getting into like routers and how routers work and stuff, you don't need to know that stuff too much. Oh, maybe even up to 170. 170, I think, is what I normally tell people. But you don't need to know the routing part of it so much unless you're going to be a network engineer. You don't need to know a lot of this. And then it gets down into some security stuff later, which, again, is a little dated, but it's still useful to know. Because overall, it hasn't changed much. All right. Anyways, that's that stuff. And then understanding how the data flow and where these things happen, this is where we start to dig into like our TCP dumps and like our Wireshark, pulling up Wireshark, seeing what's going on. ROV said, as a paramedic of 9 years transitioning in cybersecurity, self-study for 4-ish months now, I appreciate your education. Nice. Yeah, ROV, if you ever want to like sit around and talk down in the Discord, we do quite a bit of stuff. If you are hyper-focused on cybersecurity and you do Linux, we do have our security engineering course, which this was all the blue team side of Linux security. So it was like building out servers securely, connecting them to the internet securely, and connecting them to the network, giving users access, setting up bastions, which is how we allow people in through like secured networks, updating systems and how we patch, monitoring, so log monitoring, and then also alerting, configuration drift, and then keys. So we did all these things for people. That's a free book that's out there if anybody wants that here. But yeah, hopefully you get in there and find something that's super useful. A lot of people want to get into cybersecurity, and I tell you, the better your basics are, the better I think your chances are getting in over there. Some of you guys know, while I am a Linux engineer and I've done a lot of that type of engineering in my time, I also have been a red team lead for a pretty big company. Well, AAA, if anybody cares. Huge insurance company, right? Definitely in the top 10 in the U.S., even though insurance isn't where they started. They started out as a car club. All right. So, let's pull this back over here. I'm still just reviewing stuff that I'm going to talk about later in the group. So, stepping through the OSI model, understanding how the data flow, where they get put into these different parts. I show you guys about maximum transmission units, and like if our network is larger than, like if our packet is set to do not fragment, and then we try to fragment it down into the data link layer, we're going to start to have problems. And we can cause those problems if we want. We can also force packets to be fragmented if we're trying to bypass firewalls and stuff. There's all kinds of stuff that we can do once we get into packets and frames and the way that things interact and get put together in a network. So that being said, we're going to be doing a red team. So we did all the blue side of things, protecting systems, and we're going to do all the offensive stuff here. I haven't really committed to when that course is going to start, but I'm thinking like September, because I got a lot of stuff to do in August and early September. So maybe like later in September we'll start that. So it'll probably go September, October, November, maybe even into December, because it'll be a 10-week course, and it's going to be doing all the red team stuff. I'll show you guys all the same stuff that I did when I did that professionally for a little bit. So step through the OSI model. All right, so then the next one, this one is really, I think of these next ones here in the level, so in the level of how much you need to know about the system. So in symptom diagnosis solution, this is how doctors tend to do it, right? And when you think about this requires an expertise in systems, but it does not require an expertise in this system. What do I mean by that? What I mean by that is you may understand Linux, and you may understand how Linux interacts with a network, and you may understand your ping and your TCP dump and all those, the ngrep and all these other tools. That's funny, ngrep. So you may understand those, but you might not understand the system you're in. So symptom diagnosis solution is like a doctor. An ear, nose, and throat doctor may understand people's ear, noses, and throats, but he's never met you before. So then he or she, I guess, looks at your symptoms. They come up with what the likely diagnosis is, and then they create a solution path, right? Like a way to treat it or whatever. So this is a thing that you can do if you are, like I tell you guys, and some of you probably think I'm kidding, but as like a Linux engineer, people are going to be like, well, that guy's a problem solver, so pull him in on this API thing, this API software thing. And you're like, I don't write APIs or software. Yeah, but you're a problem solver. So, because this is a thing, and it really is a thing, if you get well known as somebody who can troubleshoot well, they will pull you in on everything, and that's fine. It's fine, you can just watch Netflix while you argue with people. But but the point is, you understand symptoms, look at what's going on. And you may just ask somebody, well, what do you expect to be happening here? Well, I should be getting a 200 whatever, 200 response, but every fifth call I get a 300. And you're like, is 300 bad? Well, it means moved, but it still works. Yeah. Okay. Now let's figure it out. And then, so you may have to ask clarifying questions because you're not an expert in that system, but you understand the process, right? So looking at symptoms, and then identify what's likely causing it. Again, what we were talking earlier, you've got a load balancer, because almost exclusively you got a load balancer in front of some APIs. You're never just going to be hitting an API directly. You're going to have something doing reverse proxy work to send it to multiple. And then you say, well, what's different between them? And then they go, oh my gosh, one of these systems didn't get upgraded. And by the way, that's the second time I've used that same example, because that happens a lot, guys. Because sometimes it just takes some third party to come in and look. Have you guys ever written a paper, and they always tell you to read a paper backwards, read the paragraph backwards, and then you're like, God, that just stands out like a sore thumb, but then you have somebody that you look at it, and they're like, what the hell's that word? And you're like, God, I've been looking at that word all week. That's not even a word, right? That happens to people. You get it's almost like a snow blind. You're just so used to looking off at the horizon that you don't even see what's going on with the up close. So yeah, you get in there, look at symptoms, identify the most likely cause, and then treat it. So if I were to come in on a system and my server was trying to ping Google, and every third or fourth connection was not going through and it was failing, well, I would go look at the routing table and see if there's something happening there. I would go make sure that I could connect out, make sure that when I do connect out, I'm always going to the same endpoint. Make sure that that's not an internal routing problem in my system. And then if I was getting out every time, but then not getting maybe the next hop all the time, I would start to ask, well, hey, it seems to be outside of the system. Is there something in between there that's causing different router paths or some different paths? And then come to find out something has changed over there. Some configurations changed, right? But the point is we look at the symptoms, we identify a most likely cause, and then we treat it. That requires only expertise in systems, not in that system. This one right here, I think, is the hardest because this requires expertise in systems and it requires expertise in this exact system. Meaning, you have probably been with this system for a long time. You understand how things are supposed to interconnect, right? So systems thinking is analyzing all the interdependent components. So you understand the front end, the load balancer, whatever, reverse proxy, whatever you want to call it. Typically, they're called load balancers, but they're just acting as reverse proxies. You understand the application layer. You understand the back-end data layer, and then like, hey, how do they interconnect? What's the system supposed to do? How does the data flow? And if the data is not flowing, why is it not flowing? How is that query happening? Do we have the low-level, what we call trace level data for this process as it moves through the system to be able to see which system made the call, which connection to the database is happening? Is that going slower than normal? We can see all of these individual components, but again, it requires a deep expertise of this exact system to know how it's flowing. Back earlier, I was talking about databases and how the databases were within like a millisecond time. And I said that we would all get called in, all hands. And I remember during the day, we got called in over the time. I was with that company for about 8 years total. And I remember that of like the 7 or 8 times I got called in for it, every single one of them, every single time that database had slowed down was because some new dev pointed at the real production database and didn't know it. And you say, should they have been able to do that? Absolutely not. But they read some doc or they did something or whatever, and they were pointing and they were doing queries against the live database that was our production database and not their replica data that they were supposed to. That was it every single time. And you say, every time? Yes, over the years, every single time. Say, why didn't they put guardrails up? I don't know. I can just tell you for sure that's what happened every time. And every time it was all hands, Linux, networking, database team, everybody was on this. All the dev teams that participated in those, which was a lot of them. And every time it was always some new dev was doing something they shouldn't do, doing some long running query. And it was weird. All right. So what are the system or devices between this device and the network device that's attempting to communicate? What are the other devices that are trying to communicate at the same time? Some servers behave admirably up until 4,999 connections, but they get that 5,000th connection and they just fall over. That's what we call fit for warranty or fit for, this is what we call a, in our testing, what is that called? It's a non-functional test, right? Functional tests are does it do its job. Non-functional tests are how does it behave in the wild with everything else working. So has something changed in the environment? Do you have good change management to track that? That's all huge. And then this is just kind of like, I think this is like almost like a non sequitur, but has the system been physically moved recently? That is very rarely the case nowadays. But some of you that work with virtual machines and things move between ESXi hosts or whatever, that could be a thing. I've had it where, and this was early on before, I think that tool is called like DRM that does the V-motioning automatically, where some server would get moved, but then it wouldn't be able to connect anymore because the network connections were all there, but not all of the VLANs were there. And that was just a nightmare. So once we got that fixed and stopped that from happening, cluster devices would stay where they were supposed to and it wouldn't happen. But it's not always physically moved anymore. Sometimes now virtual machines move, so that could be a problem. We try not to move virtual machines that are in physical or in prod, right? We try not to move prod stuff too much if we can avoid it. All right, so systems thinking. And then Kepner-Trego, this is a model that does situational analysis, problem analysis, decision analysis, and they do potential problem analysis. So they evaluate things that could be problems in the future. Typically for situational analysis, they're telling you to define the problem clearly. You're in the middle of an incident and you practice actually making sure that the problem is exactly what they want. I would get called out all the time back in the day for a system being down. And I would get up and I would go to my jump box. I always get in my jump box. And I would ping that box and then I'd get on the call and I'd be, guys, I can get to the box. What do you mean? Oh, the service is down. The service is down. Oh, well, that's different than the system being down. 100% that's different to me. Because now I have to go look, has that server been rebooted recently? typically yes, right? But let's say it has been, sure. So now the system rebooted, but the service didn't come up. Has something changed, right? And then all these kind of things start to happen. Hey, you said late to the party. Yeah, Cuddlingus definitely got a job, so that's awesome. That we used to do these little kings to you things, which I picked up from the Count of Monte Cristo. You know, you give somebody king for a day, which I think is funny because also he did that before he betrayed him. But I guess they had done it for years before that, and it doesn't matter. But the point is, yeah, Cuddlingus, it's their day. They got a new job. They're a Linux admin now officially, so then they can work themselves up to engineering and drinking with their pinky up like we all do now, right? As Linux engineers. I'm just kidding. So then, and then problem analysis is use questions like what, when, where, and how to understand the problem's nature. This is when we're digging into where things are happening, what the kind of what we call like a root cause analysis. Problem analysis in Kepner-Trago is also one of these like what's systemic, what's kind of always happening there. And then decision analysis, evaluate and choose the best decision or solution, figure out where you're going to go, and then potential problems. All right, so all of that was just admin stuff. That's what admins do: network operations, bridge calls, stand-ups, reporting up, and all that kind of stuff. Chris said, I'm sorry, what's his name? I probably messed up. Oh, did it say his name the right way now? Cuddlingus? Cuddlingus. Not like Colonel Angus. Anybody remember that from Saturday Night Live? All right. So, real quick before we do this, let's let this run. Where's Lily at? Lily's not on her bed. So Lily is our I guess my in-laws' dog, and Lily came and stayed with us last night. So James is here, Chris is here. I'm gonna take a quick break, guys. I'm gonna go hourglass, and let's say take a break. We'll do 10 minutes. 10-minute break. I'll be right back. If you guys have question marks, remember to !ask, and it will interrupt me and ask me a question. But I'll be back. Shunya's here. Man, everybody's here. All right, take a quick break, guys. We'll get back to failure modes and effects analysis. We're doing engineering troubleshooting next. All right. So while we're waiting, yeah, smoke them if you got them. What are you guys working on today? Anybody doing anything fun? Anybody getting out there and seeing stuff? How's Lily doing? Hold on. Lily is... So, guys, Lily is not replacing Ranger. Lily has been around, has been in the family for a long time. However, I had retired Ranger Cam, but then since Lily was coming over to stay with us last night because the in-laws were going up out of town, Lily just comes and hangs out with us, and she has figured out the doggy door pretty well, so she can go in for sure. I don't think she's figured out how to go out yet. She's not the brightest dog I've ever run into, but she's pretty good. She was popping up yesterday a little bit, so we'll keep an eye out for her and see if she goes and lays down over there. She was playing with Ranger's llama. Or actually, that's his giraffe there. His llama's still in the box, but anyways, we'll see if Lily shows up. We're still on break, so anybody doing anything fun? Hayes, looks like you're around. I imagine you still have a job after the the last problem you said you had. Hopefully that all sorted itself out. I remember you were saying somebody messed something up. Shunya, Chris, you guys are all over there. I think I told you guys I sprung for the app for Excalidraw, so I got some stuff I want to draw out for one of my customers. It's just they don't have a good drawing of like what their cluster kind of looks like, so I'm going to work on that for them. And then we have the basic stuff that we draw out there on how our cluster kind of works as well. So I've got a bunch of things to draw. Also, they've got a really cool function in there now where if you use Excalidraw, I don't know if that's only a professional version, you can draw individual scenes and turn them into like a PowerPoint right there. And it'll just bounce around between the different scenes on the page. So I'm going to start doing that as well a little bit. Yeah, Hayes, every day is, yeah, the horrors persist, but so do I. That's like, there's a reason that shirt exists, especially from an engineering standpoint. And it's funny when you're like trying to maintain systems and you're like, how the hell did this ever work the first time? Let alone, how is this thing still working? ROV, you also study dog behavior, so if you have a question, let me know. My name's Rover. Yeah, that is actually pretty good. We had Ranger Dog up until July 3rd, but he was having a lot of health issues. He was almost 14, and Lily looks a lot like him, but he was a little more golden. She's much more white. She's a very white lab, or I think she's lab retriever. I'm not sure exactly what she is. She had 2 boys. Yeah, we got a pets or family section, Rover. So people love pets around here. But yeah, we get to borrow Lily when the in-laws go out of town. So yeah, Hayes. Lily showed up a couple times on stream yesterday. I don't know if anybody clipped it or not, but it was pretty good. So that should be good. Also, I do need to one of these days here coming up, I'm going to re-record live the Socratic method, so we have like a little bit better background and just make that recording a little better. So the Socratic method, the way we have it written right now, takes about 10 or 11 hours to go through. So it'll definitely be broken up into a couple streams. That's a long time. Yeah, Rover. Yeah, people love dogs around here for sure. So, all right, I'm going to give people the last few minutes here, and then I'm going to pull this back over, and we'll keep talking about our system stuff. But failure modes and effects analysis, super useful, super good way of doing things if you want to like apply engineering to systems. I'm going to show you guys an example that I actually used with it to make things better. Let's see what we got here. All right. Almost ready. We can go. I'll give people one more minute to come back or so. One more last little minute. Let's check real quick. Make sure there's nothing going on here. Engineering troubleshooting. So this is our methodology here. And if anybody needs the recording of what we're talking about, it's all right here. So lots of information and notes to go look up. And then I think, speaking of the Socratic method, I think the guys put something at the bottom of this. I think they put the Socratic Linux down here. So here are the questions if you want to ask yourselves questions and think about your understanding of Linux. This is all something for you to play with as well. All right, let's pull this back over while that's kind of moving. And failure modes and effects analysis. So this is a method developed by the, do I have it right here? Yeah, it's a military and government technique from the 50s. It's been around a long time. But what does failure modes and effects analysis attempt to do? It wants to identify or list all possible failure modes. So within a system, what can go wrong? If we know what can go wrong, then we can start to assess what the severity, occurrence, and detection are for each of them. And then we can start to assign what's called a risk priority number to them and figure out what we think is it's a triage method, right? What is the most important thing for us to take care of? Where should we spend? We have 1,000 hours of people to work on this. Where should we be focusing our effort to try to fix these problems that are coming up? Okay. Hazy said, just did a new music jam. Going to take a bath. Hey, post it in the Discord. Post it in, I don't know, general or off topic, wherever you think it works. You can post you can put stuff in the Twitch or YouTube if you post it on YouTube. You can put it in that section if you want to. Saturday is the only day you can get stuff done. I spent the last 3 partying at the lake. Well, you got to enjoy summer when you can. Phoenix is only getting to like 103 today, so we're having a really mild summer as far as that goes. Some of you guys go 103. Well, 1, that's Fahrenheit. And 2, man, we were at like 118 when I left in July. At the beginning of July when I went down to Mexico, we got to 119 right before I left. So now it's kind of tapering off. We even had clouds yesterday. Like as the sun was going down, we had clouds, which was super nice. No, 103 is 100. It's very mild for us. That's 100% mild, because Phoenix can get like an oven out there, and it's pretty okay. What went wrong? Dumpster fire. Yeah. So so we identify, we assess, and then we prioritize our risks. This is what we're doing with FEMA. Well, failure modes and effects analysis, not FEMA like the people that are always messing up response, right? Failure modes and effects analysis. So, what is it trying to do? It's trying to examine what could go wrong. If things go wrong, what are the impact of them? What are the likelihood of it occurring? And what is our ability to detect and react to it? All of those things are going to feed into a risk priority number, which is going to give us, it's one of these things where I could just look around, like I could look over, all of my battlefield, let's say, if I were like maybe I was in charge of a bunch of tanks, and I go, well, I feel like the color of the tanks is the problem. And they're like, you feel like that, sir? Like, General, you feel like that? No. What we could do instead is we could figure out that, like, maybe tanks with a taller profile have much more chance of being hit. That is actually true. Like, the higher your profile, the more surface area you have, right? But the point is, I could have my guys go do some research and assign things, and we could figure out what the real problems are instead of us subjectively think. This is a way to objectively think about what we can fix inside of a system. I'm using tanks as an example. It was 116 when you were out here. Yeah. It's Phoenix can get pretty bad. I think we had a couple 120s last year. In fact, we had last July. So we call it so it's triple digits if you get over 100, right? But then if you get over 110, that's a whole different category of heat. And last July, I think you can look it up, we broke a record, because normally I think July had like 18 days over 110 or something. But last July, every day was over 110, except for the last day of July. If it had broken, they would have had to set up a new record of a different type, because the 110 would have been broken. But now, like, as last year and this year didn't do it. So last year was the one day off, and this year I don't even think we got close. Action, you said, what degrees would you be cooked? So it's funny. I remember when I was in the Army, I read a lot of studies on different things they had done on people. And like in humidity, you can die in like the 110 range. If there's humidity out and that. But then they took somebody and they put them in like an oven and they baked them. So Ekshani asked a question about what temperature would kill you. And they were using Australian soldiers. I don't know why they used Australian soldiers for this, but in this study, they took all the humidity away, so it was completely dry, and they put the heat up on this guy to 450. And he didn't stay there very long before they had to bring it down and get him out, but he survived because your body, when it can cool itself effectively, can go pretty high up before he finally had to tap out or whatever. So anyways, yeah, with humidity, you die almost immediately, but without humidity, they can bake you pretty good. But anyways, but it's terrible, man. Like 115 in Phoenix is terrible. So let's talk about how we prepare for this. We need to think about the system functions. We are dealing with these vastly complex systems that we build. So we build Linux systems, right? And we do that. But then there's their interaction with the networks. There's their interaction with their storage. There's the interaction that they have with maybe identity and access management stuff. So there's all these interactions where it's playing with all these different areas. So one of the things that as you're preparing for failure modes and effects analysis is you got to think about what's in scope and what's out of scope. So are we talking about this system and its subsystems? Are we talking about just this system base build? Like if we're talking about hardening a box, we're talking about just the base system. The hardening of the communications to the other things that's a separate type of functionality, right? So where I'm going with this is you think about the system and you start to break down the components you want to look at. In the case of what I'm going to show you guys is I was building systems. I'll give you guys the story here in a second. I think it's the next slide. But so we'll decompose the system and figure out what we're going to actually be looking at. Are we looking at individual parts or assemblies or subsystems or what are we looking at? Okay. In my case, so I'm going to show you how to execute failure modes and effects analysis and the way that I did it. And the way that I did it, if Michael Pessa's ever around, he's one of the guys down in our Discord. He comes and talks to you guys pretty regularly. Probably 3 or 4 times a year he comes and talks to the group. And he and I, we had this process for, we were, when dev teams, we had about 200 dev teams that we would support. So we did all the Linux. And they could come and they could push a button. They could push a button on a web page inside of a thing called VRA. And they would push this button in a catalog and say, I would like one server. I would like the server to have this much storage, and they could pick 600 gig block chunks up to, I think like 2.5 gigs or something on a box. Or sorry, 2.5 terabytes on a box. But it was like 600 gig blocks at a time. And then they had these pools of resources that they could use for memory, and they could choose the size of the box and the number of CPUs and the backend storage and all these things, right? So when they did that, though, it would go and it would kick off, VRA would kick off against a tool called VRO, which is vRealize Orchestrator from VMware, right? It's their orchestration tool. Very few people have ever used it. People that use it love it, but very few companies have the resources or you have to have people dedicated to running this tool. Then in there, it would go and it would take like our golden image, our Linux hardened golden image, and it would turn it into its own server. It would kick off some scripts and run some stuff. And then all of our stuff, me and Michael Pessa, we had all this stuff that was written in Ansible that would go and add like an Avamar agent for backup. And it would add if it was in a dev or a prod environment, it would get different Active Directory customization with SSSD, and it would get joined to the domain. And just all these things that would happen in individual playbooks based on, if they carved up their disks that they wanted, most of those disks were for applications, therefore they would go and /opt as their own directories for whatever applications they wanted. And if the applications were in our catalog, we would also kick off and install their applications. This was all automated. They pushed a button, it went and it ran all this stuff. And they were all just individual tasks that we had built inside of Ansible that then got kicked off by this vRealize Orchestrator, right? And originally they went against Ansible Core, so they were just running on a box. And then they moved over, is actually a thing that Michael did a lot of, was we had Tower, and he put all those jobs into Tower, and then they were just API calls that they had to kick off against Tower from like a service Ansible account or something. Okay. Knowing all of that as a basis of what we were doing, Devs would hit a button, they would get a server. It was like a little gumball coming out of a gumball machine. You ever seen a kid put 5 cents in a gumball machine, or probably $1.50 nowadays, and then the gumball would come down, right? And then they'd get it. That's exactly how our servers worked. There was different stuff going on in the back end, and all that stuff could break, and that's what this is. So here was our thing, server builds. Maybe when they pushed that button, VRO, vRealize Orchestrator, went and tried to get a server image, and that server image was from a thing in ESXi called like I think they called it like a server library or a document library or something. They had a term for it. But that's where they kept all their images. And all of your ESXi machines needed to be able to connect to that. Well, sometimes that was offline. It wasn't often, but there would be hiccups in the network and back-end storage and stuff. That was all connected over iSCSI over high-speed links, and they had their own back-end SAN for that. But sometimes that back-end storage would be offline for the particular node that it was trying to land on, and it would fail when they hit that button. So the control that we had for it was monitoring vSphere systems. So the initial image was unavailable, that golden hardened image that we had from our Linux system that was updated to keep up with whatever vulnerabilities were there, that was there. And then the cause was, again, backend storage was offline, so they couldn't get to it. So our way of fixing it or monitoring it, this wasn't a fix, it was a monitor, was that if we monitored vSphere systems, we would know if that was happening and we would try to fix it. Okay. Another one, automation job kickoff fails. So VRO, that's vRealize Orchestrator, or system credentials are out of date. So what would happen is, again, it would build the server. So let's say it got past that first one, now it is building a server. And VRO would be kicking off individual calls against, later on, Tower. And it would be calling the Ansible playbook through like a service Ansible account. And it would boom, 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 play on the server. Well, sometimes that credential would be out of date. Okay, that was a problem. That was a failure we saw. So what was our fix? What our fix was, every morning we would build all of like the 15 different types of servers we could build and then destroy them. And if everything built correctly at the beginning of a day, that tended to mean that there wasn't any system credential problems for the rest of that day. That was our general current control to keep that from happening. All right. Then an agent register fails on the service backend. So we get the server deployed. That's the first one. We get every call to work. That's the second one. And then the third one, as we maybe built an agent or something, the agent had like maybe a cloud callback or an API key or something for like New Relic or whatever tooling. We use New Relic. And we used a bunch of other, Avamar was another one. We used all these different agents. But it couldn't call out because maybe its credentials were bad. So you say, man, that's a lot of freaking moving parts. Yeah, there's a lot of moving parts to building a server. This is why failure modes and effects analysis is so effective, because we could quantify all the things that we knew of that could go wrong, had given us headaches, had given us alert tickets and all these things, and then we could smooth it out so they wouldn't happen again. Guess what happens when you get all these things working? Now you can just watch Netflix all day, right? Because your monitors are doing all the stuff. So our fix was for that, for if there was going to be agent or credential problems with the agents we were putting on the servers, was daily build process. If all of our servers came back good at the end, we were cool. It was good. And then the last one, this one was just, this was hard to quantify, but we just failed the final build checks. We get everything done. We deploy, we kick off all the jobs, we get all the agents set up, and then at the end, when we go to hit that last button to just check everything, something fails. Well, that was an insidious type of error, because what caused it? And what's our current control? We didn't have a current control. It was a nightmare if this one happened, because sometimes they'd just push the button again and it would work, and then we'd be stuck because the server would get destroyed. We'd be stuck just like churning through logs trying to see if we had a good what happened in that server, right? And then in fact, I think for this one, we eventually, as a control, but not when I did this, we let the server live for a little longer so we could go dig in on what was happening inside the server. Race conditions, mounting of shares not happening as quickly as we hoped. There was some delay or something. All kinds of things could have happened, right? DNS not resolving correctly to start before some other things got set up. So there were some other things that we fixed later to make this better, but final build checks could just fail, and we didn't have a good control. So this is just, and this is like one page of like, I think I probably had about 3 or 4 pages of this. So this is like part of one page of all the things that could go wrong, right? This is what we would do. So then this doesn't really help us to do these things yet. This is just what's problematic in our environment. maybe there's old knowledge or their system, digging into like tickets and stuff to find these things. But in our case, I was just writing them off of the pain points that we had run into. So then what we do is we execute the failure modes and effects analysis, and we're going to calculate a risk priority number. So the risk priority number, these are the same things we just talked about, but we are going to look at customer impact. What's the impact to our customers? And this is assigned a number between 1 and 10. What's the likelihood of it happening? Like out of 1,000 server builds, maybe a likelihood of a number between 1 and 10. 1 might be like there's between 1 and 10, and then a 2 might be between like 11 and 50, and then 3, it's a severity thing, so it's a continuum. It's not exactly like, it's not 1 to 10 as far as how many times it happened out of 1,000. That's not what it is. It's a severity risk, so you got to have to kind of plan that yourself. What's our ability to detect and react? And then we get a risk priority number. Now, real quick, a little bit of math for you guys. If the number here can be between 1 and 10, and the number here can be between 1 and 10, and the number here can be between 1 and 10, what is the final output number? This is like one of those 1 plus 1 plus 1 plus 0 plus 10 times minus 12 or something, and then everybody on the internet argues because nobody remembers math from high school, right? And probably even grade school in that case. Well, hold on. Just real quick, if you had 1 times 1 times 1, what's your lowest number? What's the number you're going to get? And if you have 10 times 10 times 10, what's the highest number you're going to get? So what's the range of risk priority numbers that we could have? And we know that the higher number is more impactful to us. Anybody know? Bueller? I know that's like a 40-year-old reference, but I think it's funny still. That was Ben Stein. Bill Stein? Ben Stein. Whatever his name is. All right, anyways. It's 1 to 1,000, right? Those are the numbers. God, what was his name? Because it was, you could steal his money. Ben Stein? That sounds right. Hey, Colcus, how's it going? We're just going through what we're going to talk about today in the group later. Win Ben Stein's money. That's exactly. It was Ben Stein. And his father had been in charge of the Fed at one point. So he was considered a pretty smart guy. But he was in the movie Ferris Bueller's Day Off. And he was like explained. He was actually teaching them about tariffs, if you guys don't know that scene. But anyway, so it was 1 to 10. It was 1 to 1,000 is the risk priority number, because these can be anywhere between 1, 1, 1 and 10, 10, 10. So the number over here, risk priority, can be 1 to 1,000, right? So that is a method for finding. It's a systematic process to examine what could go wrong, what's the impact, what's the likelihood, and what's our ability to detect and react. And the net effect of it when we're done is this is the thing we need to spend the most time with, because our ability to detect and react to it is the worst, and it has a high enough customer impact that it's going to generate a higher number, and it's the most, it's like the thing I need to spend my time, my 1,000 hours the most with is this. And then next would probably be this, and this one may take the most effort, so maybe we go knock this one out. But the point is we now have something to think about, because our next thing would be, well, how many of those 1,000 hours do we need to fix each of these? Because then we can start to assign what we should be working on. So, all right. Shark, how's it going? What does detect and react mean? So detect and react is like in here, right here. It was our, like, kind of, it was based on our controls. Do we have a control to fix it or not? And in this case, like our final build checks, we didn't have a really good control. If we had good controls like we did for these other ones, that would make those numbers lower. So our detect and react is pretty low. But our final build check, I don't know. I think I just made these numbers up for the stream one time. But this should have been way higher. This should have been like a 9, and that should have been like a 7 or something. So this one probably down here should have been higher. But customer impact was really high on this one because they saw this one. They didn't see these other ones that just failed, and then we would go and push the button again and give them a server. But yeah. So anyways, there's that. So then we get into root cause analysis, right? Which is for engineers, and it's funny, this process is very easy to define. It's ask why 5 times. And then people are like, well, that's not always enough. So then we said, well, okay, until the root cause is identified. This method is simple but effective for basic issues. So we'll look at the ask why and what that methodology kind of looks like. And then we've got fishbone diagrams, which some people call Ishikawas. And we visualize all the potential causes of a problem grouped into categories like methods, machines, materials, manpower, measurements, and environments. Sometimes fishbones are much simpler than that. But sometimes they are super useful to just draw them on a whiteboard and figure out, like, what are the inputs to this system that are causing the potential problems. You know, if we have a whole bunch of servers burning up their CPUs, then we start to look at, like, how did we put them in? Did we put enough thermal grease? The ones that aren't burning up are using a different type of thermal grease. Boom, that's important. So we start to find the methods and machines and material and manpower and measurement and environment. We find that all of them are failing in one corner of our data center. That corner of our data center is before we started to do hot and cold aisle racks. So those servers are pulling exhaust in the front, or they're pulling intake in from the front and the exhaust out the back. And the intake in the front is hot because it's not being properly cooled like in other places. That is a real thing. There's all kinds of things that we can do. You heard about relentless root cause analysis. I haven't heard of that one. Let me, what are we looking at here? Good. Maybe we spelled that right. Okay. And then the last one is fault tree analysis. So this one is a top-down deductive, meaning we're looking at outcomes, right? Failure analysis in which an undesired state of a system is analyzed using Boolean logic. True, false, go this way, go that way. Switch. Some people call it like select logic. To combine to a series of low-level elements. So let's look at each of these. How do we do the 5 whys? There's an abnormal condition. Our server did not build properly. Why? Well, the error code that came out was, so we ask, why did this occur? Why did the server not build? And we go and we find that it was because, maybe from our earlier example, there was no base image. So why was there no base image? Well, because the ESXi machine did not have connection back to the backend storage. Why did that not happen? Well, because intermittently we have SAN connectivity problems in the network. Why do we have intermittent SAN connectivity issues in the thing? Well, because we have a failing switch that's been flapping, and we've been waiting for the vendor for 3 weeks or something for the, and then down at the bottom you say, why did this occur? Because the environment's unstable and we're waiting on, vendor. Whatever the solution is, maybe we didn't even know it was unstable until we got down to this question. But we would be filling out our worksheet and asking these things. And some people people hate asking whys because a lot of times stuff gets pointed at the networking team or stuff gets pointed at the storage team. Linux engineering, we're Teflon. Stuff just slides off. They know our shit works. No, I'm just kidding. But don't think like that. You'll get in trouble. But you won't get in trouble. You'll just be, people think you're an asshole. But my point is, asking the 5 whys are, you're almost like if you ever watch detective stories or crime dramas, like you're that asshole that asks the hard questions, but it's like, it's how else to put this except engineering doesn't care about your feelings. It's not like F your feelings, like some people say, but it is true that engineering doesn't care about your feelings. I mean, if every condition, every problem always points back to your team doing shoddy work or your team having bad equipment, well, we need to figure that out. We need to fix that. But root cause analysis needs to ask the questions, even if it hurts. If somebody's feelings are getting hurt, they probably shouldn't be in engineering, right? Or maybe they should realize they're not good at engineering and they should go do something else. But my point is, like, you have to ask the why, whether or not it hurts somebody's feelings. Because your feelings are irrelevant in engineering. They really are. But anyways, this is what a worksheet might look like. You can find a million of these online, right? This is just an example. Here's a fishbone or Ishikawa diagram. And what it is, so you've got some problem. My Linux servers are not being built, right? What's happening at the machine level, what's happening maybe at the measurement level, material level. So we're trying to build things. And these might not always fit correctly. They might not all be used, and they might not even be the main headers out here. but they are things that maybe are good to start. And then maybe the measurement thing is not important because we're not really measuring things. It's more about the machine and the environment and the people, maybe. You're not consulting the change management team as you build new servers, so new servers aren't getting into the change management database. So then when we go to patch things, we don't know what all the servers are because the change management team is giving us this smaller subset of servers that they have because we're not telling them about the other things. And the problem over here might be CMDB is always out of date. Now, have any of you guys worked in IT operations and IT systems? The configuration management database is always out of date. The CMDB, I could go to 100 people working in 100 different companies, and if you were like, Scott, gun to your head, what question would you ask them that you know the answer to? 100% I would ask, is your configuration management database out of date? And I would expect 100% of those 100 people to tell me it's out of date. And I would probably think like 95 out of the 100, if they knew what was going on, would tell me the CMD was out of date, or just not. And again, that's not necessarily anything other than we don't like those people. Actually, it's funny. That does actually come up as a problem in engineering. Sometimes teams don't like working with each other, and it causes engineering problems when it shouldn't. But honestly, that is true in a big scheme of things. Like a lot of times, like people don't like the CMDB people, and they call them CMDB engineers a lot of times, and you're like, oh, these people are just paperwork monkeys. Now, anyway, obviously, I'm not biased in any way. All right, so anyways, that's your fishbone diagram. All right, and then fault tree analysis looks like this. There's AND gates, there's OR gates. This looks a lot like electrical engineering, if any of you guys have dabbled in that. I've often joked around about no matter what type of engineering you get into, all engineers go back in some, they all like regress back to like electrical and mechanical engineering in some way, which is funny because like a lot of you guys probably know engineers or are engineers, and you're like, oh, I do kind of dabble in like printing and stuff. And it's like, oh, so you like putting your hand in specs and mechanical engineering type stuff, and or, oh, I do like to play with Raspberry Pis and Pi boards, and I understand the circuit diagrams and stuff. And you're like, oh yeah, because we all like. At the end of the day, all of us go back to that. But I do tell you guys often that I also think Linux is a great basis for a lot of that stuff because almost all that stuff people do has some kind of base in Linux somewhere. But anyways, here's fault events, and here's the thing: the plant burns down, and combustibles or the fire was out of control. So there's the probability of it happening, right? Ignition was either smoking or sparks or a short. And here's the probability of that occurring. Now, anybody here know if you're dealing in probability, what does probability of occurrences always add up to? Does anybody know? If I have 5 outcomes from something I do, what does the probability of all those 5 outcomes, if I were to do a tree like this, have to add up to? And these also add up to them, although they're different for a different reason. What do all probabilities always add up to if it's an outcome from one event? Anybody know? I know you guys know this. Somebody knows this for sure. If I throw this thing, and it can either land on the table or the ground, it's 100. Yeah, it's 1. It's 1. The probability is 1 or 100%. Yeah. You guys are right. So yeah, if I said this could land on the table or it could land on the floor, it might have a 0.1 or 10% chance of landing on the table and a 0.9 of landing on the floor, but that's going to add up to 1. And you might say, well, those don't add up to 1, but they do when you dig in, and I'm sure there's some other considerations there, but they essentially always add up to 1 or 100%. Yep. Okay, so that's fault tree analysis, and you can dig into that if you want to. If you're talking about Deming, what was Deming's major contribution to this world? He did a lot with Six Sigma. He also helped rebuild Japan after World War II, and he did some awesome things. So yeah, Kolkus, you're right. It's 100%. It's a probability of 1, which is 100%. He did a plan, do, check, act. So we plan, identify a problem. We implement a change on a small scale in a controlled environment. We check, we measure the results to see if the change led to an improvement, and then we act. If successful, implement it everywhere. That's called plan, do, check, act. There's a different methodology with this called, I might have it in here. No, this is all I have. PDCA, plan, do, check, act, has a couple of different variations for Lean Six Sigma as opposed to just regular. This is regular Six Sigma. The other one is in Lean Six Sigma, which tends to deal with manufacturing and specific, like, I want to say textile, but that's not the right term. It's like produce products. Hold on. Wait, is that Study Act? Yeah, Plan, Do, Check Act, Plan, Do, Study Act. Yeah, that's not the way I heard it. That's not the way I heard it. Oh, they're calling it Study Act. Okay. Here's the ISSP. Plan, Do, Check Act versus Plan, Do, Study Act. All right, anyways, that's something to play with if you guys want to. But yeah, there's a lot on this online, and a lot of this if you get into Six Sigma. I thought it was Plan, Do. It's not. All right, anyways, it doesn't matter. CPOC are suppliers, inputs, process, outputs, and customers. So if you have a process, suppliers, where the inputs, processes, and outputs coming from. So input, process, output is computer science. That's all computer science rolled up into one page, input, process, outputs. But who are the suppliers? So who is giving input into that? So who's providing the input? And then the customers are who are consuming the output. So another way to think of this is like, you've got input, process, and output. So input might be a certain set of values, but do the suppliers or the people that are trained to, hopefully they're trained to input into like a web form or something, do they know all the relevant things that need to be there? What are the required things? What are not required? And then if those inputs are there and correct, the process could get to a right output and could complete whatever task. And then is that in a way that is consumable by the customers? If you if you run a process and then you just dump a bunch of JSON on people, right? You just dump a JSON output on them, and the customers expect to know like how much they spent and when it's gonna be there, but you're giving them like, I don't know, their tracking number, but it's an internal tracking number. It's not even like a FedEx number that they could use or something. And then you're giving them like, I don't know, just some bullshit. You like dropping like their ISO time, like their when the API call happened or something. They don't care about none of that stuff. They just want to see it in like a cleaned up output. So understanding your processes are, who's inputting to the system. So this is, again, input, process, output is the computer science side of things. Most of you can stand up a web form and get like inputs and do something and get an output. Most people know how to do that. If you don't know how to do that, go to W3 schools and they'll show you how to do it in like 10 minutes. We can do this, but do we understand who's inputting and who's getting the data on the outside? And is it feeding into another system? And then is that, interaction changing? Those kind of things. There's a lot of stuff like that. James Lynch said manufacturing, design, process engineering. Yeah, I'm just talking about like engineering troubleshooting and engineering systems. So these are things that you kind of need to know, right? I'm not necessarily talking about like specific industries or anything, but yeah, manufacturing touches Lean Six Sigma a lot for sure. All right, lab tasks this week. Oh, there was no lab for this week. So this week for people, it was also Christmas week when I originally did it. And then in the troubleshooting lab, we had that. So for this course, we were just reviewing what I'm going to be talking about later. We were doing troubleshooting, right? So it was Linux Systems Administration, Unit 15 of 16. And these were the major things we were doing. The troubleshooting concepts, incidents and problems, administrative troubleshooting, and then we were just down in engineering troubleshooting and how engineers can look at processes and make them better and stuff. So people got here a little late. That's all we were doing. Kind of hanging out, working through this stuff, right? This is just a lot of this. This is also recorded, guys. This is up in the it's up on YouTube, recorded here. Unit 15. You go to this book, Unit 15. I think it's under the worksheet. There's where we recorded it on YouTube last year, right? I need to get that back so we can see your little messages. When you guys send messages, they'll pop up. I need to get that back up there for you guys. All right, so we did all that stuff. Let's see if Lily's... Oh, Lily's not on our bed. So Lily is my in-law's dog. Ranger's gone, right? Obviously. But the Lily cam is to see if Lily will go and play. Hold on. Let me go check on Lily real quick. Let me go. She's downstairs. She'll be down there for another couple hours. But let me... let's take one more quick break. Let's do like 5 minutes real quick. We'll stop this, go rotate for now. All right, I'm gonna go check on Lily. I'll be right back. You guys will see Lily pop up over here in a second. So if you guys like dogs, you'll like Lily. Lily, where you at? Where you at, Lily? Where you at, Lily? Man, did you guys see Lily fighting me? She did not want to give up that toy. She really wanted to go outside and throw it, but you guys see her? She was like fighting me. Lily was straight up fighting me for that. All right, man. Yeah, so that's Lily. That's our in-law's dog. She was downstairs. I don't know if you guys saw me just fighting her right now. She did not want to give me that toy. So I was throwing it to her, and then she's pretty good. Yeah, she's my in-law's dog. She's like just staying the night, and then she's going back in a few hours.
They were up doing like a camp. The in-laws. They were like speaking at like a kids camp. Well, my father-in-law was. My mother-in-law was just going up and hanging out with them. But they wanted Lily to have a place to hang out, so she came and hung out with us. Oh, look at her. There she is. I think Lily's 3 or 4. Not super old. Where she's sniffing over there is all Ranger stuff. All Ranger's old stuff. She's a good dog, though. Real nice. It's super funny. She's got a big doggy door here. At the in-laws' house, they let her out. You know, when she needs to go out. But here she's got Ranger's big giant doggy door. And she is, what's a nice way to say this? She is not the smartest animal I've ever met. So, she is, I was eating some Fazoli's breadsticks from last night. We love Lily, but she's not the smartest animal. She can come in the doggy door. She cannot go out the doggy door. She hasn't figured that out yet, guys. She comes in it. She came in it 7 times yesterday. I counted. We let her out the back. She ran around. We even went out and walked around out back with her. And then this morning she was playing with the ball like Ranger used to, which was kind of cool. She found one of Ranger's old balls. Yeah, sending. I mean, you know, we knew Ranger was going to go. I'm kind of glad it went before, because we were going to go to Mexico for 10 days. We went like the 10th through like the 18th or 19th, somewhere in there. And I'm kind of glad that like nobody like had to, he couldn't even stand up anymore. He couldn't even get out of his bed. So it was time. I think he was happy. He had a smile. Like I have a picture of him. He had a smile on his face. So yeah. And me and the wife both sat in there with him. You know, we're not just gonna like leave him and let him do him dirty like that. We're gonna at least sit with him. In fact, Sending Grounds, this hasn't been on since that happened, since Ranger passed, except that Lily was going to be here last night, so I switched it over to Lily Cam, and then Lily's been running in and out of stream yesterday and today. But she's going to go back in, I don't know, about 2 hours. They're going to come pick her up. So she's a good dog. She was like, she knew Ranger in his later years, but when he was still pretty active, so they would go out back and chase the ball together and stuff like that. So yeah, we like Lily. All right, so for people who are newer here or kind of want to know what's going on, we have a Discord you can go hang out in. Discord's free, doesn't cost nothing. You can go in there. There are a whole bunch of kind of beginners resources that you guys can go look around and see what's going on with the group and see kind of what we're all about. People have pets. Oh yeah, we love puppers. Oh yeah, that looks a little like Sending Grounds dog. A little bit, probably a little darker than Chloe. Chloe, right? Chloe. Oh yeah, fur missiles. I love when we have a big doggy door like this, and then they look so sad, like, oh no, we're on the other side of the doggy door. But it's really just keep you from falling down the steps, guys, right? Like that's what it is. So, yeah. Muddy Voice said, "Will I get another?" I told the wife we're getting a couple of huskies, and she's like, "We are not getting a couple of huskies," and I'm like, "Just please," and she's like, "No, that's not gonna happen." So, if we got another dog, it would probably be a little bit older dog, just so that we're hoping to avoid the puppy stage, even though I would love the puppy stage, but the wife's like, the puppy will tear too many things up, and I'm like, well, that would also bug me a lot, but because I'm older now, and I don't need a bunch of young whippersnappers running around, but I don't know, we might adopt. Like the wife really likes cats more than dogs. She also loves dogs too, though. But I don't know. Yeah, I don't know if we're planning on She doesn't want another dog. She's like, it's too hard to say goodbye to him. She hates that. But let me see. Hold on. Other people's dogs. Here we go. Phoebe, right? Is that it? Am I thinking wrong?
What would you say?
Yeah, Sandy, that's Phoebe, isn't it? Yeah. Anyway, she's got prison tats on her neck from all the people she's bitten over the years. It's not over the years. It was one discrete day, in fact. But yeah, we love the predicament. So I actually meant to say this the other day. King Buns posted this and said about the dog, the predicament. So my friend has these. He has just a whole bunch of. They really like German Shepherds, and no, sorry, not German Shepherds. He's got Dobermans. I'm getting my friends mixed up. I'm in a group on Facebook called the Poop Mouth Crew, MOUF. So it's all my dog buddies. But anyways, his dog is big enough. So one of his Dobermans is big enough to steal things off the counter. So it stole a giant This pepper was like as big as this. It was huge, bigger than the dog's mouth. And it was kind of like this right here. Anyways, it stole the pepper and it took it to its bed. And it didn't like the pepper. But it didn't want to give the pepper back either. So it was like, it was torn. Like, I've stolen this and it's mine, but I don't like it and I don't want it anymore. But I also don't want to get caught. So they just had a picture of it. Like, the dog looked like the saddest, like, most forlorn thing I've ever seen, because he's like, I'm in trouble for stealing this, but also I'm not giving it back. But I also don't want it. So it's just this funny, like, the things that dogs get into. That's kind of funny. So, anyways, yeah. This is. Why can't I think of her name? Phoebe, right? Yeah. Anyways, new puppers. We like puppers. And that looks like that's in front of like I'm colorblind, but I think that's kind of like a purplish or something cherry blossom tree. So that's pretty nice looking. Purple or pink, I don't know. I'm colorblind, but it looks something nice. I'm sure my wife will like it.
She'll appreciate it more than me.
Yeah, Phoebe. That's what I thought. Yeah. So. All right. So, interestingly enough, my Twitch shows that I'm not even streaming anymore, so that's weird. Twitch does weird shit. All right. Things we still need to do, though, is I need to let you guys know that down in the Discord, we're running the Linux sysadmin group. We're in week 15 of 16, so it's almost done. We're going to get ready to restart that and the other course, the security engineering course. But the Linux admin course probably won't run again until early next year. And the security engineering course, we're also going to run the automation course with it. So that'll be a 16-week automation for administrators. Now, that's going to bleed over into like automation for engineers too, because I don't know. I make the distinction when we talk here and when we hang out and stuff, but there's not really much distinction, guys. If you're an admin, you're going to get pulled up into engineering stuff. If you're an engineer, you're going to get pulled down into admin stuff. And that will happen in your career. But just, you got to keep churning through it as an admin for a while, not complaining about it, hopefully. And then eventually you get moved up to that pay bracket. And that's kind of nice. That's what most of us did in our career. We all just started schlepping around and working in the Linux. I started out in networking, right? And then I moved over into Linux. And actually, when I first started Linux, I was called a hardware engineer. Because at Lockheed Martin, we rack stacked. We did everything. We took the stuff out of the box and put it in the racks, right? So we did everything. So, yeah, automation is the fun part, Colchis, for sure. I would agree with that, because, like, you know, we're using tools anyways. You know, none of us are down in the assembly doing that stuff by hand. We're even at some level, we're compiling stuff from code that we've written. So everybody's doing some type of automation at some level. They're using some type of tooling. So yeah, we're trying to get that going. But anyways, yeah, the group exists for you guys. It's for people that want to get into this space. Maybe you're just a hobbyist and you're having fun and you want to get better at this stuff. This is the group. And yeah, the official study group. So Colchis is still here, but the study group's going to start in a few minutes. So if you guys want to go work in about 5 minutes down, start working on Bash, you can do that. You'll see people populate and then they'll be down the study channels here somewhere in the voice. You guys are always welcome to go hang out down there, right? So there's that. We've got our later Linux admin course where we're going over the same stuff I just showed, but I'll get down in there and we'll walk through some of it and make sure people understand as much as we can how it applies to the industry and that kind of stuff. There's an admin study group during the week, so Zorgel runs that. I think he's already been through the course, but he's working through it again, so that's good. Or maybe he came in later and did only start this time. I forget. But then we've got our big course. Like, this is our big end of the year celebration for us, which is on the 6th year anniversary of us being in Discord. And I just got a whole bunch of different public speakers and guest speakers for you guys from around the industry. They're going to tell you about how to get into some of this stuff. So, Leith said, how do I edit the presentation? Yeah, so Leith, if you need to change yours, I believe you belong to a group that you should just be able to click on it and go to edit right here. If you don't have those powers, let me know. But I think you have those powers. I think all the people that are talking have those powers. Gotta find Leith. Where's Leith at? I'll find you here in a little bit off stream. But yeah, Leith, you should be able to go and click on it and show whatever you need to out of there. But for everybody else, there should be stuff down in general. There should be just a lot of people talking about stuff in the tech space and stuff that gets there. Yeah, Agalord. Yeah, pink, purple. Worst for colorblind. Yeah, actually, the one that gets me the most, Agalord, is blue and purple, because purple is just blue with some red in it, and if I can't see that shade of red, it's blue. So me and the wife often joke around about my favorite color is blue, but well, it could also be purple, I guess, but I wouldn't know. So maybe my favorite color is blue because I saw so much blue, because I don't see purple. So yeah, it's kind of funny. One thing you'll never see me do, guys, you will never see me argue with somebody about color. If it's a black and gold or a green and red dress, I don't fucking know. Like, you're right, whatever, I don't know. Like, I literally wouldn't be the one to argue with you about it, because I'm already colorblind. So there's nothing else worse than that. There's a lot of things worse than being colorblind. I'm just saying, like, somebody who's colorblind arguing with other people, I'm always going to be wrong. So I'm not going to do it. You don't have the power, Leith? All right, I'll make sure you have the power here in a little bit. Unless you just want to message me and I'll change whatever you need. That's fine too. Sending grounds, you don't have permissions? I thought for sure all of our ProLUG engineers had permissions. Okay, I'll look. I'll look at what the permissions are, because I think it's just like there's a group permission. I gotta add it like here in members. Guys, we're almost at 4,100 people too. We're getting there. We're at 4,092. So there's no real major thing to cross it. 4,100. It's not. This time last year we were barely breaking 1,000 people. So we're growing. Trying to tell you guys about getting into Linux, getting into engineering. I tell you guys often. Sometimes you love Linux and you don't want to be an all the time Linux engineer because you're like, well, I really like doing this stuff on the side. Guys, there's all kinds of other things that are just Linux adjacent. Like, Linux can be your basis, and you can go be a security engineer, or you can be you can be a project manager if you want. But Linux is an awesome basis for getting into tech. So, as Agalord said, first job in tech was technically a front-end web dev, and every time people ask me to change the color on something, I have to tell them hex code or bus. Yeah, just give it to me in that. Yeah, that's so I really like those ones where you can just GIMP does it, and I think, what's that other tool? Somebody just gave me another tool the other day for stuff, but where I can just color pick and it gives me the hex. I love it. Is that hex? Yeah, is that hex code? Yeah. That's I like that. Or RGB or whatever that is. Any of those where I can just click the color and pick it. That's my favorite, because then I don't have to guess what the color is. I can just go click on the pixel. That's my favorite. Yeah, and any of you guys, again, the Bash study group is starting, so you could go and hang out with people, go make some friends in the space, right? That's the thing. Like, you just got to go find people that are doing the same type of stuff as you and are interested in the same type of stuff as you. Because I'm convinced that's a big part of getting into all this. Sitting with the engineers and admins and figuring out how other people are doing it. So, all right. Yeah, let me make sure these guys have the right permissions and all that good stuff. So, here's what we're gonna do, guys. I've been talking a lot, so I'm gonna take a little bit of a break. I gotta go yell at my college students at high noon, so there's always that. Let's go to our little end of stream. We're gonna end it for the YouTube side of things. I appreciate all you guys over on YouTube coming and hanging out with us. I will see you guys later on in the week. Tomorrow we'll be doing all labs, right? Sundays are for labs, so we're getting up early.